Making millions of Reese's peanut butter cups a day takes more than just chocolate and peanut butter. It's a precision-engineered process that runs around the clock. Inside massive factories, advanced machines mix and mold every cup with perfect consistency and flavor. In this documentary, we take you behind the scenes to reveal the fascinating process behind America's most iconic treat. The creation of Reese's peanut butter cups is a meticulous process that begins with the careful selection and preparation of peanuts, the cornerstone of the product's distinctive flavor and texture. This journey starts with sourcing high-quality peanuts, primarily from regions renowned for their optimal growing conditions, such as Georgia and Texas. These areas provide the ideal climate and soil composition, resulting in peanuts with the desired size, flavor, and oil content essential for the signature Reese's taste. Upon arrival at the manufacturing facility, the peanuts are subjected to a rigorous inspection process. Advanced optical sorting machines, equipped with high-resolution cameras and sensors, meticulously scan each peanut, identifying and removing any that are discolored, misshapen, or contaminated with foreign materials. This ensures that only the finest peanuts proceed to the next stage, maintaining the high-quality standards synonymous with Reese's products. Following sorting, the peanuts undergo a thorough cleaning process. They are funneled through a series of air classifiers and vibrating screens that effectively remove dirt, stones, and other debris. Some facilities may also employ water baths or steam cleaning methods to ensure an even higher level of cleanliness. This step is crucial, as any residual impurities could adversely affect the flavor and safety of the final product. The next phase involves roasting the cleaned peanuts to develop their rich, nutty flavor and achieve the desired texture. Industrial roasters, such as continuous belt roasters or rotary drum roasters, are employed to ensure even roasting. The peanuts are exposed to temperatures ranging from 320 degrees Fahrenheit to 350 degrees Fahrenheit for a specific duration, typically between 30 to 60 minutes. The exact time and temperature are carefully controlled and adjusted based on factors like peanut variety and moisture content to achieve the optimal roast profile. During roasting, the Maillard reaction, a chemical interaction between amino acids and reducing sugars, occurs, contributing to the development of complex flavor compounds and the characteristic golden brown color of the peanuts. Continuous monitoring of temperature and airflow within the roasters ensures uniform roasting and prevents over or undercooking, which could compromise the flavor and quality of the peanut butter filling. Once roasting is complete, the peanuts are rapidly cooled to halt the cooking process and preserve their flavor profile. This is typically achieved by passing the hot peanuts through cooling conveyors equipped with powerful fans that circulate ambient air. Rapid cooling prevents the peanuts from continuing to cook from residual heat, which could lead to undesirable flavor changes or textural issues. After cooling, the peanuts are transferred to blanching machines, where their skins are removed. Blanching involves exposing the peanuts to steam or hot air to loosen the skins, followed by mechanical rubbing or abrasion to peel them away. This step is essential, as peanut skins can impart a bitter taste and affect the smoothness of the peanut butter. The blanched peanuts are then inspected once more to ensure all skins and any remaining impurities have been effectively removed. The blanched peanuts are now ready for grinding, a critical step in transforming them into the creamy peanut butter that fills each Reese's cup. The peanuts are fed into industrial grinders, which consist of a series of grinding plates or mills that progressively reduce the peanut particles to the desired consistency. The initial grinding stage breaks the peanuts into coarse pieces, while subsequent stages further refine the texture, resulting in a smooth, creamy peanut butter. Throughout the grinding process, the peanut's natural oils are released, contributing to the creamy consistency of the peanut butter. To achieve the perfect texture and prevent oil separation, stabilizers such as hydrogenated vegetable oils may be added. These stabilizers help maintain the emulsion of peanut solids and oils, ensuring the peanut butter remains smooth and spreadable over time. Temperature control during grinding is paramount. Excessive heat generated by friction can alter the flavor and consistency of the peanut butter. To mitigate this, cooling systems are integrated into the grinding equipment, maintaining the peanut butter at an optimal temperature and preserving its quality. Once the peanut butter reaches the desired consistency, it is transferred to stainless steel storage tanks equipped with agitation systems. These systems keep the peanut butter uniformly mixed, preventing the settling of solids and ensuring consistency across batches. The storage tanks are part of a closed system that protects the peanut butter from exposure to air and potential contaminants, preserving its freshness and flavor until it is needed for the next stage of production. Now, it's time to delve into the preparation of the chocolate coating that envelops the peanut butter filling, giving Reese's peanut butter cups their iconic taste and texture. The chocolate used is a carefully formulated blend designed to complement the peanut butter's flavor while providing a smooth and satisfying mouthfeel. The process begins with the selection of premium cocoa beans, sourced from regions known for their high-quality cocoa production, such as West Africa and South America. These beans are fermented and dried at their origin to develop the foundational flavor characteristics essential for quality chocolate. Upon arrival at the manufacturing facility, the cocoa beans undergo roasting, a process that further develops their flavor and reduces moisture content. Industrial-scale roasters, similar to those used for peanuts, are employed to ensure even roasting. The beans are roasted at temperatures between 250 degrees Fahrenheit to 320 degrees Fahrenheit for durations ranging from 30 to 60 minutes, depending on the desired flavor profile. Continuous monitoring ensures consistency and prevents over-roasting, which could impart bitter notes to the chocolate. After roasting, the cocoa beans are cooled and subjected to winnowing, a process that removes the outer shells, leaving behind the valuable cocoa nibs. These nibs are then ground into cocoa mass, also known as cocoa liquor, which serves as the base for all chocolate products. The grinding process generates heat, causing the cocoa butter within the nibs to melt and form a liquid mass. To create milk chocolate, the variety used in Reese's peanut butter cups, the cocoa mass is combined with specific proportions of sugar, milk solids, and additional cocoa butter. This mixture undergoes refining, where it is passed through a series of rollers to reduce particle size, resulting in a smoother texture. Achieving the optimal particle size is crucial, as it influences the mouthfeel and overall quality of the chocolate. Following refining, the chocolate mixture undergoes conching, a process involving continuous mixing and aeration at controlled temperatures. Conching serves multiple purposes. It further smooths the texture, develops flavor by promoting the evaporation of undesirable volatile compounds, and ensures a homogeneous blend of ingredients. The duration and temperature of conching are carefully controlled, with longer conching times typically resulting in superior flavor development. Once conching is complete, the chocolate is tempered to stabilize its crystalline structure. Tempering involves carefully cooling and reheating the chocolate to specific temperatures, encouraging the formation of stable cocoa butter crystals. Proper tempering ensures that the chocolate sets with a glossy finish, has a satisfying snap, and resists blooming, a condition where fat or sugar crystals rise to the surface, creating a dull or streaked appearance. The tempered chocolate is maintained at a precise temperature in holding tanks, ready for the enrobing process. These tanks are equipped with gentle agitation systems to keep the chocolate uniformly mixed and at the correct viscosity for coating the peanut butter filling. But up next is the integration of the peanut butter filling and the chocolate coating, a process that demands precision and synchronization to achieve the perfect balance between the two components. Specialized machinery is employed to deposit measured amounts of peanut butter onto a base layer of chocolate, ensuring consistency in size and weight for each cup. The process begins with the formation of the chocolate shell. Molds, typically made of polycarbonate or stainless steel, are filled with a specific amount of tempered milk chocolate, dispensed through precision-controlled nozzles. These molds then pass through a vibration station which ensures the chocolate evenly coats the bottom and sides of the mold cavity. This vibration also helps eliminate any air bubbles that could compromise the integrity or appearance of the finished product. The amount of chocolate deposited and the intensity of vibration are both tightly regulated, ensuring uniformity across thousands of cups produced per hour. Once the molds are coated, they are inverted and lightly spun in a controlled environment. This inversion allows excess chocolate to drain off while still leaving a consistent layer adhered to the inner surfaces of each mold. This stage is crucial. Too much chocolate can overwhelm the peanut butter filling, and too little can lead to structural failure of the cup during demolding or packaging. The molds then proceed through a cooling tunnel, typically kept at temperatures between 45 degrees Fahrenheit and 55 degrees Fahrenheit. The cooling phase ensures that the chocolate shell partially sets to the correct hardness before it receives the peanut butter filling. As the molded chocolate shells emerge from the cooling tunnel, they are transported to the filling station. Here, a high-speed depositor arm, equipped with precision temperature and viscosity control, deposits the peanut butter filling into each partially set chocolate cup. The filling temperature is typically maintained between 85 degrees Fahrenheit and 95 degrees Fahrenheit, warm enough to flow smoothly, but cool enough not to melt or deform the chocolate shell. The depositor is calibrated to deliver an exact volume of filling per cup, down to a fraction of a milliliter. This exactness is essential for product consistency and for ensuring that the peanut butter doesn't spill over the edges when the top chocolate layer is added. The formulation of the peanut butter filling used in Reese's is slightly different from traditional peanut butter. It is intentionally thicker and drier in consistency, achieved by controlling the moisture content and fat levels during the grinding and mixing process. This formulation helps the filling maintain its shape during deposition and ensures it doesn't mix into or bleed through the surrounding chocolate. The peanut butter also contains a precise blend of sugar, salt, and stabilizers, all tailored to produce the sweet, slightly salty, and crumbly texture unique to Reese's cups. After the filling is deposited, the molds move on to receive the final chocolate layer. This top layer of tempered chocolate is again dispensed with precision, covering the peanut butter entirely and sealing the cup. The exact thickness of this layer is calibrated to ensure a perfect balance between the two flavors and to provide structural integrity once the product is unmolded. If the chocolate top is too thin, it risks cracking during cooling and handling. Too thick, and it throws off the flavor harmony. The fully assembled peanut butter cups then enter a second cooling tunnel. This tunnel is longer and colder than the first, typically operating between 35 degrees Fahrenheit and 45 degrees Fahrenheit. Here, the final chocolate layer sets completely, bonding with the underlying components and solidifying the cup into its final form. Conveyor belts inside the tunnel are carefully speed regulated so that the cups spend the exact amount of time needed to fully crystallize the cocoa butter without overcooling, which could lead to bloom or textural issues. As the cooled and fully set cups exit the tunnel, they are transported to the demolding station. This is a delicate and crucial phase where the now solid chocolate cups must be removed from their molds without cracking, chipping, or leaving any residue behind. Modern factories use pneumatic or mechanical release systems that gently flex the molds while applying a quick burst of air from underneath each cavity. This loosens the cups and lifts them onto a secondary conveyor without physical contact from human hands, preserving hygiene and preventing product damage. Now it's time to go into the inspection and quality control stage, a multi-layered process where each Reese's peanut butter cup is evaluated for conformity, appearance, and safety. As the demolded cups travel along the inspection conveyor, they pass through high-resolution vision systems equipped with artificial intelligence software that scans for imperfections. This includes checking for chips in the chocolate, uneven layers, off-center fillings, or improperly formed edges. Cups that do not meet the strict visual criteria are automatically rejected by air jets that direct them off the main line and into collection bins for disposal or reprocessing, depending on company policy and food safety regulations. In addition to visual checks, random samples are pulled at regular intervals for more in-depth testing. These samples are weighed to ensure they meet exacting product specifications. Other tests may include breaking the cup in half to examine the internal peanut butter to chocolate ratio, or using texture analyzers that measure the product's resistance to pressure, an indicator of proper tempering and filling density. Chemical testing is also conducted regularly to verify the correct balance of sugar, moisture, fat, and salt in the filling. These tests are often performed in on-site quality control laboratories, where technicians run batch samples through a range of analytical equipment, such as moisture analyzers, gas chromatographs, and spectrophotometers. If any irregularities are found, production is paused, and corrective measures are implemented. This could mean recalibrating a depositor nozzle, adjusting roasting temperatures for peanuts, or even reviewing the supply chain for ingredient inconsistencies. But up next is the packaging stage, which begins with the alignment of the peanut butter cups into lanes that feed into high-speed wrapping machines. These machines are capable of wrapping hundreds of cups per minute, and they must do so without damaging the fragile chocolate shell. The wrapper material is typically a laminated foil paper composite, selected for its barrier properties against oxygen, moisture, and light, all of which can degrade product quality over time. Each wrapper is printed with the Reese's branding, product information, batch codes, and expiration dates using thermal or inkjet printers. As the cups enter the wrapping station, they are placed onto rotating belts that synchronize with the wrapper feed. A roll of pre-printed wrapping film is continuously pulled into position, cut to size by high-speed blades, and sealed around each cup using heated crimpers. The sealing temperature and pressure must be carefully controlled to ensure an airtight seal without melting the chocolate inside. Once wrapped, the cups are grouped for secondary packaging. They may be placed in cardboard sleeves, plastic trays, or directly into multi-unit bags, depending on the product configuration. These groups are then placed into larger cartons for shipping. Before sealing, a final barcode scanner checks each item to confirm it matches the correct SKU and batch. Any errors trigger an automatic halt in the packing line to prevent cross-contamination between different product types. Every carton is weighed and scanned one final time before being sealed, labeled, and moved to the warehouse staging area. From here, pallets of Reese's peanut butter cups are logged into an inventory system and scheduled for distribution to retail locations across the country. Every step from peanut to pallet is tracked with traceability data, ensuring full accountability throughout the production cycle. Now it's time to go into the warehousing and distribution phase of Reese's peanut butter cup production, where the finished products transition from tightly controlled factory environments to large-scale logistics operations. Once the individually wrapped and secondary packaged cups are assembled into master cartons, these cartons are loaded onto pallets. Each pallet holds a predefined number of cartons, strategically arranged to optimize space while maintaining product integrity during transport. Automated palletizers equipped with robotic arms or gantry systems handle this process with precision, stacking cartons with minimal human intervention to ensure efficiency and reduce labor costs. Once a pallet is completed, it's secured using high-tensile stretch wrap, often applied via automated rotary arm or turntable wrapping machines. This stretch film not only stabilizes the load, but also provides a moisture and dust barrier, safeguarding the products during storage and shipping. Pallets are then labeled with barcoded shipping tags that include vital information such as product codes, batch numbers, production dates, and destination data. These barcodes are integrated into the factory's centralized inventory management system, allowing for real-time tracking and traceability from the moment a product leaves the production floor. The wrapped and labeled pallets are then moved to climate-controlled storage areas within the facility's warehouse. These storage zones are maintained at stable temperatures, typically between 55 degrees Fahrenheit and 70 degrees Fahrenheit, to ensure the chocolate remains in perfect condition. Extreme heat can cause melting or blooming, while excessive cold may alter texture or create condensation that can compromise the packaging seal. Environmental sensors continuously monitor these storage areas, and any deviation outside preset tolerances triggers alerts for immediate corrective action. Warehouse operations are managed by advanced warehouse management systems, which direct the flow of goods through automated guided vehicles or forklifts, guiding them to the optimal racking locations based on FIFO principles. This ensures older inventory is shipped before newer batches, reducing the risk of aging stock reaching consumers. Some high-output facilities even use fully automated storage and retrieval systems, where robotic cranes handle all inbound and outbound movement of pallets without human input. As orders come in from distribution centers, retail chains, or e-commerce platforms, the WMS generates pick lists, directing operators or picking robots to assemble the correct products for shipment. During the picking process, each item's barcode is scanned again to confirm accuracy. Pallets are then loaded onto temperature-controlled trucks or shipping containers, with the logistics team carefully planning routes and loading sequences to match delivery schedules. The transportation phase is critical in preserving product quality. Trucks used to transport Reese's peanut butter cups are often equipped with refrigeration units to maintain stable conditions, especially during warmer months or in hot climates. Real-time GPS tracking and telematics systems allow logistics managers to monitor vehicle locations and environmental conditions inside the trailers, ensuring any issues can be addressed proactively. Once the Reese's cups arrive at regional distribution centers, they're cross-docked or stored temporarily before being sent to individual retail locations. Cross-docking minimizes storage time by immediately transferring incoming goods to outgoing trucks, improving freshness and reducing inventory holding costs. At the retail level, automated shelf replenishment systems and electronic point-of-sale data further refine logistics by signaling when to restock based on actual consumer purchases, closing the loop between factory and final sale. Now it's time to explore the role of factory automation and digital systems that underpin every phase of Reese's peanut butter cup production. From peanut sorting to final product distribution, automation enhances consistency, efficiency, and food safety across the board. At the front end of the process, smart sensors and machine vision systems oversee raw ingredient inspection. These tools can detect flaws invisible to the human eye, such as slight discoloration, mold, or the presence of foreign matter, ensuring that only the highest quality peanuts and cocoa beans enter the process. Programmable logic controllers orchestrate the flow of operations on the production line. These industrial computers are connected to every piece of equipment, from roasters and grinders to depositors and cooling tunnels, and execute real-time instructions based on input data. For example, if a change in peanut moisture content is detected by inline sensors, the PLC can automatically adjust roasting time or temperature to compensate, maintaining flavor consistency. Supervisory control and data acquisition systems provide plant operators with a bird's-eye view of the entire production environment. With these interfaces, managers can monitor batch progress, verify line speeds, track downtime, and receive alerts if any machinery falls out of spec. Every action taken by machines is logged for traceability, which is particularly important for food safety compliance and auditing purposes. Data collected from SCADA systems can also be analysed for continuous improvement, helping to identify bottlenecks, optimize throughput, and reduce energy consumption. Robotics play a crucial role in packaging and material handling. Articulated robotic arms, equipped with suction grippers or vision-guided end effectors, perform tasks such as picking and placing cups into trays, applying labels, or stacking cartons. These robots can work around the clock without fatigue, dramatically improving productivity while maintaining precision and reducing injury risk for human workers. Factory hygiene and sanitation are also managed with the help of automation. Clean-in-place systems are installed throughout the facility to automatically flush and sanitize processing lines between batches. These systems circulate heated cleaning solutions through tanks, pipes, and machinery to remove peanut residue and chocolate buildup, all without disassembling equipment. Sensors measure cleaning effectiveness in real time, ensuring that microbial standards are met and that no allergenic cross-contact occurs between production cycles. But up next is the innovation behind product design and the proprietary formulation that gives Reese's peanut butter cups their legendary status. While the general public recognizes the product for its flavor, texture, and iconic shape, much of the success lies in the precise engineering of ingredients and design. The ratio of peanut butter to chocolate has been refined over decades of experimentation, resulting in a balance that optimizes sweetness, saltiness, creaminess, and firmness. Hershey's R&D teams use texture analysis, sensory panels, and predictive modeling to test thousands of variations in ingredient proportions before locking in a final formula. Ingredient consistency is paramount. For instance, the type of sugar used in the peanut butter filling is selected not just for sweetness, but for its ability to control water activity and crystallization during storage. The salt content is finely tuned to enhance the peanut flavor without becoming overpowering, while milk powder used in the chocolate is selected for both its taste and its emulsifying properties. Even minor fluctuations in these ingredients can affect the final mouthfeel and flavor, which is why tight supplier controls and internal batch testing are enforced. The cup shape and wrapper design are also engineered with precision. The signature fluted edge of each Reese's cup isn't just a visual cue, it aids in demolding and adds structural strength. The cups are formed using molds with concentric grooves that create this pattern as chocolate is spun or vibrated up the walls. The wrapper is designed to peel off easily without sticking to the chocolate, which requires selecting specific coatings and materials that interact correctly with cocoa butter at varying humidity levels. In recent years, innovation has also extended to creating new product lines, miniatures, thins, big cups, and seasonal shapes. Each variant requires its own custom set of tooling, depositor calibrations, and process flow adjustments to accommodate differences in fill volume, chocolate thickness, and packaging format. These product changes often involve months of pilot testing on R&D lines before being scaled to full production. Engineers simulate the behavior of chocolate and peanut butter under different conditions using computational fluid dynamics models, ensuring that no matter the shape or size, the Reese's experience remains consistent. Every year, the production line adapts to create special seasonal versions of Reese's peanut butter cups, which introduces another layer of complexity to the manufacturing process. For Halloween, pumpkin-shaped cups are crafted, while Christmas brings tree-shaped varieties and Easter features egg-shaped versions, all of which require entirely different molding systems. Instead of the standard fluted cup molds used year-round, these limited editions use custom-engineered molds with unique contours that must still ensure even chocolate distribution, stable cooling, and a clean release during demolding. These seasonal shapes often necessitate recalibrating the chocolate depositor systems and modifying the cooling tunnel timings, since broader or thicker designs may set at different rates than standard cups. The journey of M&M's production begins long before the candies take their familiar shape. It all starts with sourcing the finest raw ingredients, ensuring that only the highest quality materials make their way into the manufacturing process. The primary component of M&M's is chocolate, which requires premium cocoa beans. These beans are cultivated in tropical regions across the globe, primarily in West Africa, South America, and parts of Southeast Asia. The selection of cocoa beans is an extremely meticulous process, as the quality of the beans directly impacts the flavor and texture of the final product. Once the cocoa beans are harvested, they are fermented to develop their rich chocolate flavor. This is a crucial step that involves placing the freshly gathered beans in wooden boxes or spreading them out on banana leaves, where they are covered and left to ferment for several days. During fermentation, the beans undergo chemical changes triggered by naturally occurring bacteria and yeast. This process reduces the beans' natural bitterness and enhances the complexity of their flavor profile. Regular stirring and aeration ensure even fermentation, and expert cocoa farmers monitor the process closely to prevent over-fermentation, which could compromise the beans' quality. After fermentation, the beans are dried under the sun, further intensifying their chocolatey aroma. The drying process can take several days and must be carefully managed to prevent mold growth. The dried beans are then packed into large sacks and shipped to chocolate manufacturers, including those that supply chocolate for M&M's production. Once the cocoa beans arrive at the processing facility, they undergo rigorous quality control checks. Samples are taken from each shipment to assess various characteristics such as bean size, moisture content, and aroma. Any beans that fail to meet the strict standards are discarded or repurposed. The approved beans then move on to the cleaning phase, where they pass through specialized machines equipped with powerful air jets, sieves, and magnets to remove unwanted debris such as dust, stones, and plant matter. The thorough cleaning ensures that only pure cocoa beans proceed to the next stage of the process. With the beans cleaned and sorted, the next step is roasting, a critical phase that brings out the rich, deep flavors of chocolate. The roasting process is highly controlled and varies depending on the desired flavor profile. Beans are placed into large rotating drum roasters, where they are exposed to carefully calibrated heat, typically ranging from 250 to 350 degrees Fahrenheit. The length of roasting time can vary from 30 minutes to over an hour, depending on the type of chocolate being produced. As the beans roast, the heat triggers complex chemical reactions, including Maillard reactions and caramelization, which contribute to the depth and complexity of the chocolate flavor. Roasting is not just about flavor. It also helps loosen the thin outer shell of the cocoa bean, making it easier to separate the nibs, the inner, edible part of the bean, from the husk. Once roasting is complete, the beans are cooled rapidly to halt further cooking. They then move to the winnowing stage, where they are cracked open, and the husks are separated from the nibs using a combination of sieving and airflow. The husks, now removed, are often repurposed for agricultural use or discarded. Now it's time to transform the roasted nibs into a smooth, rich chocolate base. The nibs are passed through heavy-duty grinding machines, where they are ground down into a thick liquid paste known as cocoa mass or cocoa liquor. This grinding process generates heat, causing the natural cocoa butter within the nibs to melt and blend with the cocoa solids. The result is a velvety, rich substance that serves as the foundation for all chocolate products, including the chocolate cores of M&M's. At this stage, the cocoa mass is still quite bitter and lacks the smoothness associated with high-quality milk chocolate. To refine its texture and taste, it is mixed with additional ingredients, including sugar, milk powder for milk chocolate varieties, and more cocoa butter. The exact proportions are carefully controlled to ensure consistency across every batch. The blended mixture is then sent through refining rollers, which grind the chocolate particles to an incredibly fine texture, reducing them to just a few microns in size. This refining step is crucial for ensuring the signature smoothness of M&M's chocolate. But up next, the chocolate must undergo a crucial process known as conching. Conching is an intensive mixing and aeration process that enhances both the texture and flavor of the chocolate. Large, specialized machines equipped with rotating paddles continuously churn the chocolate mixture for several hours, or even days, depending on the manufacturer's specifications. During conching, heat and friction help to evaporate unwanted volatile acids, mellowing the chocolate's flavor and reducing any residual bitterness. This step also ensures that the chocolate reaches an exceptionally fine and uniform consistency, eliminating any remaining graininess. Once conching is complete, the chocolate must be tempered, a carefully controlled process that ensures the chocolate has a stable crystalline structure. Tempering involves heating the chocolate to a precise temperature, cooling it slightly, and then reheating it to another specific temperature. This controlled cooling and reheating process encourages the formation of stable cocoa butter crystals, which give M&M's chocolate centers their signature snap and glossy finish. If chocolate is not properly tempered, it can develop a dull, chalky appearance and an undesirable, crumbly texture. With the chocolate now perfectly tempered, the next step is forming the small, round chocolate cores that will become the centers of M&M's. The tempered chocolate is dispensed into specially designed molding equipment that shapes the chocolate into tiny, uniform spheres. These chocolate pieces are rapidly cooled to solidify their structure, ensuring they maintain their perfect shape. Once solidified, the chocolate centers are ready for the next stage of production. But before the chocolate centers can move on to the next phase, they undergo another round of quality control. Sophisticated scanning and sorting machines inspect each individual piece for size, shape, and texture consistency. Any chocolate pieces that do not meet the exact specifications are removed from the production line and either reprocessed or discarded. At this point, the chocolate cores are complete, but they are still missing the signature crunchy sugar shell that makes M&M's so iconic. To prepare for the coating process, the chocolate pieces are carefully transferred to large rotating drum machines where they will be transformed into the colorful candies known around the world. Now it's time to begin the intricate process of coating the chocolate centers with their signature sugar shell. The process starts with a sugar syrup mixture made from granulated sugar and water, which is heated to an exact temperature to achieve the correct viscosity. The sugar syrup is prepared in carefully monitored mixing tanks to ensure consistency across every batch. Once the sugar syrup is ready, the chocolate cores are placed into large rotating coating pans. These specialized pans are designed to gently tumble the chocolate centers, allowing for even application of the sugar coating. The sugar syrup is added in small increments, gradually building up the shell layer by layer. After each application, the candies are briefly dried using controlled airflow to harden the sugar coating before the next layer is applied. This step is repeated multiple times, as the sugar shell must reach the perfect thickness to provide the signature crunch that M&M's are known for. Throughout the coating process, precise measurements are taken to ensure each M&M receives an even and consistent sugar shell. The candies are inspected at multiple stages to verify their size, shell thickness, and overall quality. Any irregularly shaped pieces are removed to maintain the brand's strict standards. Now it's time to explore one of the most intricate and carefully controlled stages of the M&M's manufacturing process, the creation of the colorful sugar shell. This step is essential as it gives M&M's their signature crunch, vibrant appearance, and prevents the chocolate core from melting in consumers' hands. The process of coating the chocolate centers in sugar is not a simple one. It requires multiple layers of application, precise drying techniques, and exacting quality control measures to ensure that each candy turns out perfectly. The process begins with preparing the sugar syrup, which serves as the base for the outer shell. This syrup is made by dissolving high-quality granulated sugar in water and heating it to an exact temperature to achieve the desired consistency. The proportions of sugar and water must be carefully controlled to ensure that the final coating will be thick enough to provide a satisfying crunch while remaining thin enough to allow for a smooth, even color application later in the process. Large industrial mixing tanks continuously stir the solution to maintain uniformity, preventing sugar crystals from forming prematurely, which could create an undesirable, grainy texture in the shell. Once the sugar syrup is prepared, the chocolate centers that have been formed and cooled in the previous step are placed into massive rotating coating pans. These pans, also known as dragee pans, are large, circular drums that spin at a carefully controlled speed, allowing the candies to tumble evenly as the sugar syrup is applied. The process of coating the chocolate centers in sugar is known as panning, and it is a delicate operation requiring expert control over temperature, humidity, and airflow. The first application of sugar syrup is extremely light, providing only a thin base layer that helps the subsequent layers adhere properly. After each addition of syrup, a controlled airflow is introduced to the rotating pan to help dry the layer and prevent the candies from clumping together. The drying step is just as critical as the application itself. If the sugar syrup remains too wet for too long, it can result in an uneven coating or cause pieces to stick together, leading to misshapen M&Ms. This layering process is repeated multiple times, gradually building up the shell to its final thickness. Each new layer of syrup must be carefully measured and evenly distributed across all the candies in the pan to ensure a uniform shell thickness. The factory uses automated sensors to continuously monitor the weight and diameter of the candies, ensuring that each M&M receives the same precise amount of coating. If any inconsistencies are detected, adjustments are made in real time to correct the issue. The drying process also plays a key role in determining the final texture of the shell. Factories use sophisticated drying chambers that regulate temperature and humidity with extreme precision. The drying process must strike a perfect balance. Too much heat too quickly can cause the sugar to crystallize unevenly, leading to a rough texture, while too little heat can leave the shell sticky and prone to damage. Airflow systems within the factory ensure that the drying process occurs gradually and consistently across every batch. The next challenge in the sugar coating stage is ensuring that the candies remain perfectly spherical as the layers build up. If the panning speed is too high or the syrup is applied unevenly, the candies can develop a slightly oblong or irregular shape. To prevent this, highly skilled operators oversee the process, adjusting pan rotation speeds and syrup application rates as needed. The use of vibration sensors and laser scanning technology further helps detect any irregularities in shape, allowing for real-time corrections. Throughout this process, thousands of tiny M&Ms are tumbling together in the massive coating pans, yet they must all maintain a uniform appearance and size. To achieve this, the factory employs a combination of mechanical precision and human oversight, ensuring that every step of the sugar coating process adheres to the highest quality standards. This level of detail and control ensures that every M&M that makes it into a package is identical in texture, thickness, and size. But up next, now that the sugar shells have reached the correct thickness, it's time to introduce the vibrant colors that make M&Ms so instantly recognizable. However, before any color is applied, the candies are still a plain white or light beige color, lacking the bright and varied hues that consumers expect. The process of adding color is just as intricate as the coating process itself, requiring precise dye applications, careful drying, and rigorous quality control checks. The first step in coloring M&Ms is preparing the food-safe dye solutions. Each color, red, yellow, blue, green, orange, and brown, is created using a carefully controlled blend of FDA-approved food colorants mixed with water and a small amount of sugar. The color solutions are stored in separate stainless steel tanks, each dedicated to a single hue, ensuring that no cross-contamination occurs. These solutions must be continuously stirred to maintain an even distribution of the dye particles, preventing any inconsistencies that could lead to color variations in the final product. The M&Ms are then divided into different batches, with each batch destined to receive a specific color. The candies are transferred back into the rotating coating pans where the coloring process begins. Rather than applying the dye all at once, it is carefully sprayed onto the candies in multiple ultra-thin layers, allowing the color to gradually build up. This layering technique prevents the formation of streaks or uneven patches, ensuring a flawless and uniform appearance. The rotation of the pans ensures that every candy receives an even coat of dye, but this process must be monitored closely to prevent oversaturation, which could lead to color bleeding or an overly thick coating. The amount of dye applied is measured with extreme precision, and factory technicians continuously test samples to confirm that the color matches the exact shade required by the brand's strict specifications. If even the slightest variation in hue is detected, adjustments are made immediately to correct the issue before the batch proceeds further. After each layer of color is applied, the candies undergo another round of controlled drying. The drying process at this stage is particularly important because it ensures that the color sets properly without smudging or transferring onto other candies. A carefully balanced combination of warm air and controlled humidity is used to dry the candies gently, preserving the integrity of the color while maintaining the smooth texture of the shell. Once the final layers of color have been applied and the candies have fully dried, the next step is polishing, which gives M&Ms their signature glossy sheen. The polishing process involves adding a small amount of food-grade glaze, such as confectioner's glaze or carnauba wax, to the coating pans. As the pans rotate, the candies rub against each other, naturally buffing their surfaces to create a smooth, reflective finish. This step not only enhances the visual appeal of M&Ms, but also serves a functional purpose. It prevents the candies from sticking together during packaging and transportation. Now that the M&Ms have their final color and shine, they must go through one of the most iconic steps in the entire production process: the printing of the signature M on each piece. But before the candies can be stamped, they must be carefully arranged so that each one is properly oriented for printing. High-speed conveyor belts and automated sorting systems position the candies with their flattest surface facing upward, ensuring a consistent print placement. The printing process itself uses an advanced offset printing technique, which allows for rapid and precise application of the white M logo. A specially formulated food-grade white ink, made primarily from titanium dioxide, is applied to a flexible printing pad, which then transfers the design onto each individual candy. The pressure of the printing pad is carefully calibrated to ensure that the ink adheres without smudging or distorting the logo. But this process is not without its challenges. Each M&M must receive a perfectly centered M that is clear and consistent in size. High-speed cameras monitor the printing process in real time, scanning each candy to detect any misaligned or incomplete prints. If a candy does not meet the strict printing standards, it is automatically removed from the production line. This ensures that every M&M that reaches consumers is perfectly branded with the recognizable M logo. With the printing process complete, the M&Ms now have their final appearance, but they must still undergo rigorous quality control inspections to ensure they meet every specification before packaging. This final inspection phase uses advanced laser scanners, weight sensors, and visual inspection technology to detect any defects, such as size inconsistencies, color variations, or improper printing. Any candies that do not meet the standards are removed and either reprocessed or discarded. Now that the M&Ms have their final color, shine, and the iconic M printed on each piece, it's time to move into the packaging stage. Packaging is one of the most important steps in the entire process because it ensures the candies remain fresh, protected, and properly portioned for consumers. The packaging process must be extremely precise, as millions of M&Ms are produced daily, and each bag must contain the exact amount of product while maintaining the highest quality standards. The first step in the packaging process is sorting and portioning. The freshly finished M&Ms are transported from the production area to the packaging lines using specialized conveyor systems designed to prevent damage to the candies. These conveyor belts move the M&Ms in a controlled manner, preventing excessive friction or sudden impacts that could cause the candies to crack or chip. Before the candies reach the filling machines, they must be properly mixed to ensure an even distribution of colors in each package. To achieve this, large rotating drums mix the M&Ms together, creating a balanced blend of all the different colors. This step is crucial because consumers expect a diverse mix of colors in every bag, and any imbalances could lead to dissatisfaction. Sensors continuously monitor the mixture to ensure that no single color is overrepresented or missing from a batch. Once the M&Ms are thoroughly mixed, they move on to high-speed weighing machines that measure out exact portions. These machines use advanced load cell technology to ensure that each package receives the correct weight of product, whether it's a small single-serving bag or a large bulk container. If the weight of a portion does not fall within the acceptable range, the machine automatically adjusts the portion size or rejects the package, ensuring that every bag contains the precise amount of candy. After portioning, the M&Ms are funneled into packaging machines that fill them into different types of containers. The most common packaging formats include small plastic pouches, resealable bags, large family-size packs, and rigid plastic tubes. Each packaging type requires a different filling technique. For flexible bags, the M&Ms are dropped into pre-formed pouches, which are then sealed using heat and pressure to create an airtight closure. For rigid containers, such as tubes or bulk dispensers, the candies are carefully dispensed in controlled amounts to prevent breakage. One of the most critical aspects of the packaging process is sealing. The packaging must create an airtight barrier that protects the M&Ms from moisture, air, and temperature fluctuations, all of which could compromise their texture and flavor. Heat sealing technology is used for pouches and bags, ensuring a strong, tamper-proof closure. For resealable bags, a zipper-style closure is incorporated into the design, allowing consumers to open and close the package without compromising freshness. Each package is then labeled with important product information, including the expiration date, batch number, and barcode. These labels are applied with high-speed printing systems that ensure clear, legible text. The batch number is particularly important because it allows for traceability in case of any quality control issues. If a problem is detected in a particular batch of M&Ms, manufacturers can quickly identify and recall affected products using this tracking system. Before the packaged M&Ms are sent out for distribution, they must pass through a final quality control checkpoint. This stage involves multiple inspection systems designed to detect any defects or contaminants. X-ray machines scan the sealed packages for any foreign objects, such as metal fragments or plastic particles, ensuring the highest level of food safety. Optical scanners verify that each package contains the correct mix of colors and that there are no visual defects in the candies. Weight checking systems also perform one last verification to ensure that every package falls within the acceptable weight range. If any package is found to be underfilled or overfilled, it is automatically rejected and sent back for reprocessing. This level of precision is essential for maintaining consistency across all M&M's products. Once the M&Ms pass the final quality control checks, they are grouped together and packed into larger cartons for distribution. The individual packages are stacked inside shipping boxes in a way that maximizes space efficiency and prevents movement during transportation. These cartons are then sealed and labeled with shipping information, including the destination, lot number, and handling instructions. Now that the M&Ms are packaged and ready to go, the next step is distribution. The packaged candies are loaded onto pallets and transported to regional distribution centers, where they are sorted based on their final destinations. From these distribution centers, the M&Ms are shipped to retail stores, vending machine suppliers, and online fulfillment centers. The logistics of M&M's distribution are highly optimized to ensure that products reach consumers as quickly and efficiently as possible. Temperature-controlled storage facilities are used to prevent the candies from melting or degrading during transit. This is particularly important in warmer climates, where exposure to high temperatures could cause the chocolate cores to soften and the sugar shells to become sticky. To maintain freshness and ensure a long shelf life, M&Ms are stored in climate-controlled warehouses before reaching store shelves. The shelf life of M&Ms can be up to 12 months, thanks to the airtight packaging and stable sugar shell that protects the chocolate from external factors. Retailers follow strict inventory rotation policies to ensure that the oldest stock is sold first, preventing any expired products from reaching consumers. Once the M&Ms arrive at retail locations, they are displayed in strategically placed sections of stores to maximize visibility and sales. The packaging design plays a key role in attracting consumers with bright colors and clear branding, making M&Ms easily recognizable on store shelves. In addition to traditional retail stores, M&Ms are also sold through vending machines, online retailers, and specialty candy shops. While the journey from raw cocoa beans to finished M&Ms is highly complex, the end result is a candy that is loved by millions of people around the world. The precision, technology, and craftsmanship involved in every step of the manufacturing process ensure that each M&M meets the highest standards of quality and consistency. But the innovation doesn't stop there. M&M's production continues to evolve with advancements in automation, sustainability initiatives, and new product development. For example, Mars, the company behind M&M's, has invested in sustainable cocoa sourcing programs to ensure that the chocolate used in their products is ethically and responsibly sourced. They are also working on reducing the environmental impact of their packaging by exploring recyclable and biodegradable materials. Additionally, new flavors and limited edition M&M's varieties are constantly being developed, requiring modifications to the production process. Whether it's peanut butter-filled M&M's, crispy rice varieties, or seasonal flavors, the core manufacturing process remains the same. But new ingredients and formulations require precise adjustments to maintain the signature M&M's experience. The continuous pursuit of quality and innovation is what has made M&M's one of the most enduring and beloved candies in the world. Every bag, from the smallest single-serving pouch to the largest party-sized container, goes through the same rigorous process to ensure that it meets the expectations of consumers. To create the world's most beloved hazelnut and cocoa spread, the manufacturing facilities are equipped with advanced machinery, precision-engineered systems, and rigorous quality controls. Each step in the process is optimized for efficiency, consistency, and the highest standards of food safety. In this detailed breakdown, we'll explore how Nutella is made inside a modern factory, from the raw materials to the final product, with a close look at the construction, operation, and technical aspects of the factory's systems and machinery. The process begins with the sourcing of raw ingredients, including hazelnuts, sugar, cocoa powder, palm oil, skim milk powder, and vanillin. These ingredients are delivered to Nutella factories in massive quantities, requiring large-scale handling infrastructure. Hazelnuts, one of the key components of Nutella, are often sourced from Turkey and Italy, two of the largest hazelnut producers in the world. Upon arrival at the factory, hazelnuts are stored in enormous silos or temperature-controlled storage rooms to maintain their freshness. The silos are made of food-grade stainless steel and designed to protect the nuts from humidity and contamination, while allowing for precise dispensing into the production line. The first step in processing the hazelnuts is cleaning. Hazelnuts arrive in bulk shipments, often mixed with debris such as shells, stems, and dirt. To address this, the factory uses a series of cleaning systems that include vibrating screens, air classifiers, and magnetic separators. The vibrating screens shake the nuts to separate them from larger debris, while the air classifiers blow away lightweight impurities like husks and dust. Magnetic separators are also used to detect and remove any metallic particles that might have entered the shipment during harvesting or transport. Once cleaned, the hazelnuts undergo visual inspection using high-speed optical sorting machines equipped with cameras and sensors. These machines identify and remove any defective hazelnuts, such as those with discoloration, cracks, or signs of mold. After cleaning, the hazelnuts move to the roasting stage. Roasting is a crucial step in developing the rich, nutty flavor that characterizes Nutella. In the factory, this is achieved using massive industrial roasting ovens. These ovens are designed with rotating drums or conveyor belts to ensure even roasting. The temperature is carefully controlled, typically ranging between 280 and 320 degrees Fahrenheit, depending on the size and moisture content of the hazelnuts. Sensors monitor the temperature and time to ensure consistency, as over-roasting can lead to bitterness, while under-roasting can result in a lack of flavor. The entire roasting process is automated, and the equipment is designed for continuous operation to handle the high volume of hazelnuts required for production. Once roasted, the hazelnuts are transferred to grinding machines. These machines are equipped with heavy-duty stainless steel blades and rollers that crush the nuts into a fine paste. The grinding process occurs in multiple stages, with each stage further reducing the particle size of the hazelnut paste. In the initial stage, the nuts are coarsely ground into a chunky paste. In the subsequent stages, the paste is refined into a smooth consistency, with particle sizes measuring less than 30 microns. This ultra-fine grinding is essential for achieving Nutella's creamy texture. The equipment used in this process, such as colloid mills and ball mills, is highly specialized and designed to operate under high pressure and at precise speeds. The resulting hazelnut paste is collected in large stainless steel tanks, where it is stored at a controlled temperature to preserve its flavor and consistency. While the hazelnut paste is being prepared, the other ingredients are processed in parallel. Sugar, which provides sweetness to Nutella, is delivered to the factory in bulk containers or tankers. Upon arrival, the sugar is unloaded into silos, equipped with pneumatic conveying systems. These systems use air pressure to transport the sugar from the silos to the milling area, where it is ground into a fine powder. Industrial sugar mills are used for this purpose, and the grinding process ensures that the sugar particles are small enough to dissolve uniformly in the mixture. The factory also incorporates sieving systems to filter out any impurities or oversized sugar particles before they proceed to the blending stage. Cocoa powder, another key ingredient, undergoes a similar process. The cocoa powder is stored in sealed silos to protect it from moisture and contamination. Before being added to the Nutella mixture, the cocoa powder is sifted through vibrating screens to break up clumps and ensure a fine, even consistency. This step is crucial for achieving the smooth texture of the final product, as any clumps could create inconsistencies during blending. Palm oil, which gives Nutella its creamy consistency and prevents separation, is stored in large, temperature-controlled tanks. These tanks are equipped with heating elements to keep the oil in a liquid state, as palm oil tends to solidify at room temperature. The oil is pumped through insulated pipes to the mixing area, where it is carefully measured and added to the blend. The precise control of temperature and flow rate is essential to ensure that the oil integrates smoothly with the other ingredients. Skim milk powder, which adds a subtle dairy flavor and contributes to the creamy texture of Nutella, is stored in sealed containers or silos to prevent exposure to air and moisture. Before being used, the milk powder is sifted and screened to remove any lumps. Factories use advanced pneumatic conveying systems to transport the milk powder from the storage silos to the mixing area, ensuring that the ingredient is handled efficiently and hygienically. The blending process is the heart of Nutella's production, where all the prepared ingredients come together to form the final product. The blending tanks used in Nutella factories are massive, often with capacities of several thousand gallons. These tanks are equipped with high-speed agitators and temperature control systems. The hazelnut paste, sugar powder, cocoa powder, skim milk powder, palm oil, and vanillin are added to the tank in precise proportions, which are controlled by computerized dosing systems. These systems are programmed to weigh and dispense each ingredient accurately, ensuring consistency across batches. During blending, the mixture is heated slightly to help the ingredients combine more effectively. The temperature is carefully monitored, as excessive heat could alter the flavor and texture of the product. The blending tanks are designed to ensure even mixing, with agitators that create a vortex to incorporate all the ingredients thoroughly. The result is a homogeneous mixture with a smooth, creamy consistency. Once the blending process is complete, the mixture undergoes a refining stage. Refining is a critical step that ensures the final product is free of any graininess. The refining process takes place in multi-stage roller mills, which are equipped with heavy-duty steel rollers. These rollers apply immense pressure to the mixture, reducing the particle size of any remaining solids to less than 20 microns. This process not only enhances the texture of Nutella, but also improves its spreadability. The roller mills are fitted with precision sensors that monitor the pressure and temperature during refining, ensuring optimal performance. After refining, the mixture is transferred to the conching stage. Conching is a process borrowed from chocolate manufacturing and involves agitating the mixture in large, heated tanks for several hours. This process helps to further smooth the texture and enhance the flavor of the spread by allowing volatile compounds to evaporate and by evenly distributing the fats and solids. The conching tanks are equipped with paddles or rollers that knead the mixture continuously. The temperature and duration of conching are carefully controlled, as overconching could negatively affect the spread's consistency. The finished Nutella is then pumped into holding tanks, where it is kept at a controlled temperature until it is ready for packaging. These tanks are equipped with agitators to prevent separation and maintain the spread's uniformity. Before the Nutella is packaged, it undergoes a final round of quality control. Samples from each batch are tested for flavor, texture, color, and viscosity. The factory uses advanced laboratory equipment such as viscometers and spectrophotometers to ensure that the product meets the company's stringent standards. Any deviations from the desired specifications are identified and corrected before the product proceeds to the packaging stage. Packaging is the final step in Nutella's production process, and it is carried out with the same level of precision and efficiency as the earlier stages. The spread is pumped from the holding tanks into automated filling machines, which dispense precise amounts of Nutella into jars. The filling machines are equipped with high-speed nozzles that can fill hundreds of jars per minute. Each jar is made from food-grade plastic or glass and arrives at the factory pre-sterilized to ensure hygiene. The jars are sealed with tamper-proof lids which are applied and tightened using automated capping machines. Once the jars are sealed, they are conveyed to labeling stations, where Nutella's iconic branding is applied. The labels include important information such as the lot number, production date, and expiration date, which are printed using high-speed inkjet or laser printers. After labeling, the jars are inspected by vision systems that check for defects such as misaligned labels or damaged seals. Any defective jars are automatically removed from the production line. The jars are then packed into cardboard cartons using robotic packing systems. These systems are programmed to arrange the jars in specific configurations to maximize space and protect the jars during transportation. The cartons are sealed and stacked onto pallets using robotic palletizers. The pallets are then wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. The entire packaging process is designed for high efficiency, with minimal manual intervention and maximum output. Throughout the factory, automation plays a key role in maintaining efficiency and consistency. Programmable logic controllers and supervisory control and data acquisition systems are used to monitor and control every aspect of the production process. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. The factory is also equipped with advanced robotics and machinery that ensure smooth operation, from ingredient handling to final packaging. Hygiene and safety are top priorities in Nutella factories. Production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Air filtration systems maintain a clean environment by preventing airborne contaminants from entering critical zones. Employees follow strict hygiene protocols, including wearing protective clothing and washing their hands regularly. The factory is regularly inspected to ensure compliance with international food safety standards, guaranteeing that every jar of Nutella is safe for consumption. This intricate, highly automated process ensures that Nutella is consistently smooth, flavorful, and delicious, meeting the high expectations of its millions of fans worldwide. Every step, from the handling of raw ingredients to the final packaging, is a testament to the engineering and precision that go into creating this beloved spread. The result is a product that continues to delight consumers, one jar at a time. Peanut butter, a staple spread beloved worldwide for its creamy or crunchy texture, requires a sophisticated and highly organized manufacturing process to meet the demand for consistent quality and flavor. Behind every jar of peanut butter is an intricate factory process that starts with the raw peanuts and ends with precisely packaged jars ready for distribution. Let's take an in-depth look at the factory production process, exploring the machines, systems, and engineering techniques that make it all possible. The process begins with the sourcing of raw peanuts. These peanuts are typically grown in countries like the United States, China, India, and Argentina, which are among the largest producers of peanuts globally. Peanuts are harvested in vast quantities, cleaned and dried at their source before being shipped to peanut butter manufacturing facilities. Factories require a consistent supply of high-quality peanuts, and to ensure that the raw peanuts are often tested upon arrival for size, moisture content, and overall quality. This ensures only the best peanuts are used for processing. Upon arrival at the factory, peanuts are stored in massive silos or bins designed specifically for food products. These silos are constructed from food-grade stainless steel or coated steel to prevent contamination and ensure proper hygiene. Inside the silos, the peanuts are protected from moisture, pests, and temperature fluctuations. These storage systems are equipped with conveyor systems that efficiently transfer peanuts from the silos to the initial cleaning and processing stages. The first step in processing peanuts is cleaning. Even though peanuts are partially cleaned at their source, factories implement a rigorous cleaning process to ensure no foreign materials or impurities remain. Vibrating screens are used to remove debris such as dirt, stones, and small sticks. Air classifiers blow air through the peanuts to remove lighter debris such as peanut skins or husks. Magnets are also employed to extract any metallic impurities. Optical sorting machines equipped with cameras and sensors scan each peanut as it moves along a conveyor belt, automatically removing any defective peanuts, including those with discoloration, mold, or deformities. After the cleaning process, the peanuts proceed to the roasting stage. Roasting is a critical step in peanut butter production, as it develops the rich, nutty flavor that defines the final product. Factories use industrial roasting ovens to roast the peanuts at controlled temperatures. These ovens come in two main types: batch roasters and continuous roasters. Batch roasters are used for smaller production lines, while continuous roasters, which use conveyor belts to move peanuts through a heated chamber, are used for larger scale operations. The temperature in these roasters typically ranges from 300 to 350 degrees Fahrenheit. The roasting process is closely monitored with temperature sensors and automated control systems to ensure the peanuts are roasted evenly. If some peanuts are over-roasted, they can turn bitter, while under-roasted peanuts may lack flavor. The level of roasting can also be adjusted depending on whether the final peanut butter will have a mild or more robust taste. Once roasted, the peanuts are cooled to stop the cooking process. Cooling is achieved by passing the roasted peanuts through chambers with powerful fans or cool air blowers. This step is crucial because it prevents the peanuts from continuing to cook, which could lead to inconsistencies in flavor. Some factories also use a water spray system to rapidly cool the peanuts, though this is less common as it can add moisture to the product. The cooling systems are designed to operate continuously to keep pace with the output of the roasting ovens. With the peanuts roasted and cooled, the next step is to remove their skins and separate the kernels. Skin removal is done using blanching machines. These machines have rotating drums or abrasive rollers that rub the peanuts, causing the thin outer skin to flake off. Some systems use steam blanching, where the peanuts are exposed to high-pressure steam to loosen the skins before mechanical removal. After blanching, the peanuts pass through air classifiers that blow away the loose skins, leaving behind clean peanut kernels. Factories also use gravity separators to sort peanuts by size and density, ensuring that only uniform peanuts proceed to the grinding stage. Before grinding, the peanuts are inspected again for quality. This is done using high-speed optical sorters that ensure any remaining defective peanuts are removed. Factories often have automated weighing and proportioning systems at this stage to determine the exact amount of peanuts needed for each batch. This level of precision is crucial for maintaining consistency in the flavor and texture of the peanut butter. The grinding process is the heart of peanut butter production. The roasted peanuts are fed into industrial grinders, where they are crushed into a fine paste. This process happens in multiple stages, beginning with coarse grinding and followed by finer grinding. The equipment used for this includes hammer mills and roller mills, which are specifically designed to reduce the peanuts into small, uniform particles. In many factories, the particle size is reduced to less than 20 microns, which is smaller than the diameter of a human hair. Achieving such a fine consistency is essential for the creamy texture that many consumers expect from peanut butter. For crunchy peanut butter, the process is slightly different. In these cases, a portion of the peanuts is coarsely ground and set aside before the final blending stage. These larger peanut pieces are later mixed into the smooth paste to create the characteristic crunchy texture. To prevent the peanut butter from separating, stabilizers such as hydrogenated vegetable oils or palm oil are added during the grinding process. These oils help bind the natural peanut oils to the solid peanut particles, ensuring a smooth and stable product that doesn't separate in the jar. Salt and sugar are also added at this stage to enhance the flavor of the peanut butter. Factories use precision dosing systems to measure and add these ingredients in exact proportions, ensuring every batch has the same taste. After grinding, the peanut butter is sent through a mixing stage, where it is further blended in large stainless steel tanks equipped with high-speed agitators. This stage ensures that the stabilizers, salt, and sugar are evenly distributed throughout the peanut butter. These tanks are often heated slightly to keep the peanut butter at the right consistency for mixing. The temperature is carefully controlled, as overheating can alter the flavor or texture of the peanut butter. Once the mixing is complete, the peanut butter undergoes quality control checks. Samples from each batch are tested in an on-site laboratory for flavor, texture, and consistency. Advanced instruments, such as viscometers, are used to measure the viscosity of the peanut butter, ensuring it meets the desired standards. Factories also use particle size analyzers to confirm that the peanut butter's texture is smooth and uniform. These quality checks are critical, as even slight variations can impact the final product's appeal to consumers. The final step in the manufacturing process is packaging. The peanut butter is pumped from the mixing tanks to filling machines, where it is dispensed into jars. These filling machines are capable of handling thousands of jars per hour, ensuring high efficiency. The jars, typically made of food-grade plastic or glass, arrive at the factory pre-cleaned and are sterilized again before filling. The filling nozzles are designed to dispense precise amounts of peanut butter into each jar, ensuring uniform weight and volume. Once the jars are filled, they move to the capping machines, where tamper-proof lids are applied and tightened. After capping, the jars are conveyed to labeling machines, which apply the brand's signature labels, along with lot numbers and expiration dates for traceability. Vision systems inspect each jar to ensure that the labels are correctly applied and that there are no defects in the seals or packaging. The jars are then packed into cardboard boxes using robotic packing systems. These robots are programmed to arrange the jars in specific configurations to optimize space and protect the jars during transportation. The boxes are sealed and stacked onto pallets using automated palletizing systems. Finally, the pallets are wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. Throughout the entire production process, automation plays a vital role in maintaining efficiency and consistency. Factories are equipped with programmable logic controllers, PLCs, and supervisory control and data acquisition, SCADA systems, that monitor and control every aspect of production. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. Robotic systems handle many tasks, from sorting and cleaning peanuts to packaging the final product, reducing the need for manual labor and ensuring precision. Hygiene and safety are also top priorities in peanut butter factories. The production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Positive air pressure systems prevent airborne contaminants from entering critical zones, while strict hygiene protocols ensure that employees maintain cleanliness throughout the production process. The entire facility is regularly inspected to comply with international food safety standards, ensuring that every jar of peanut butter is safe for consumption. Peanut butter production is a complex and highly technical process that relies on advanced machinery, precise engineering, and rigorous quality control. From the cleaning and roasting of peanuts to the grinding, mixing, and packaging of the final product, every step is designed to create a spread that is smooth, flavorful, and consistent. Factories operate with remarkable efficiency, producing thousands of jars per day to meet the global demand for this versatile and beloved product. Strawberry jam production is a fascinating and highly engineered process that combines precision machinery with time-tested techniques to create a smooth, fruity spread. At the core of this process are high-quality strawberries, sugar, pectin, and citric acid, all carefully handled and processed to achieve the perfect consistency and flavor. Inside a modern jam factory, every step is optimized for efficiency, consistency, and food safety. The process begins with the selection and delivery of fresh or frozen strawberries. Factories typically source strawberries from local farms or large-scale suppliers. Frozen strawberries are often preferred for large-scale production because they are preserved at peak ripeness, ensuring consistent flavor year-round. The strawberries arrive in bulk containers and are stored in cold rooms or freezers to maintain their quality until processing begins. Before entering the production line, the fruit undergoes a thorough cleaning process. This includes washing the strawberries in large tanks filled with filtered water, where gentle agitation removes dirt, debris, and any residual pesticides. Once cleaned, the strawberries pass through optical sorting machines. These machines use cameras and sensors to identify and remove defective or discolored fruit. Advanced systems can even detect minute imperfections, ensuring that only the highest quality strawberries make it into the jam. After sorting, the strawberries are sent to cutting or mashing machines, depending on the desired jam texture. For chunkier jams, strawberries are coarsely chopped, while for smooth spreads, they are mashed or pureed into a uniform consistency. The fruit then enters large stainless steel cooking kettles or continuous cooking systems. In these vessels, the strawberries are combined with sugar, which not only sweetens the jam, but also acts as a natural preservative. The sugar is added using automated dosing systems that measure precise quantities to ensure consistent flavor. Pectin, a natural thickening agent derived from fruit, is added to help the jam set. Citric acid is also incorporated to balance the sweetness and enhance the fruit's natural flavor. The mixture is slowly heated, with temperatures reaching up to 220 degrees Fahrenheit to activate the pectin and achieve the ideal gel-like consistency. During cooking, the jam undergoes constant agitation to prevent scorching and ensure even heating. Steam-jacketed kettles or vacuum cookers are often used, as they allow for rapid and uniform heating. Modern vacuum systems are particularly advantageous because they enable cooking at lower temperatures, preserving the fresh flavor and bright color of the strawberries. Throughout the cooking process, sensors monitor the temperature, pH levels, and viscosity of the jam, ensuring that the final product meets strict quality standards. Once the jam reaches the desired consistency, it is pumped through a series of filters to remove any seeds or large pieces if a smoother texture is desired. The finished jam is then transferred to filling machines. These machines dispense precise amounts of jam into sterilized glass jars or plastic containers. The jars are immediately sealed with tamper-proof lids to maintain freshness and prevent contamination. After sealing, the jars are passed through pasteurization tunnels, where they are briefly heated to destroy any remaining microorganisms. Finally, the jars are labeled, inspected, and packed into cartons using robotic packaging systems. The entire process is highly automated, ensuring efficiency and consistent quality, from the arrival of fresh strawberries to the delivery of jars to store shelves. This seamless blend of traditional cooking techniques and advanced technology ensures that every jar of strawberry jam is rich in flavor, perfectly textured, and safe for consumers to enjoy. The process begins with the careful selection and sourcing of raw ingredients. The primary components of KitKat bars include wheat flour, sugar, cocoa mass, cocoa butter, milk powder, vegetable oils, and emulsifiers. Nestlé, the brand behind KitKat, sources these ingredients from various regions worldwide, ensuring sustainability and adherence to strict quality standards. The cocoa used in KitKat is primarily sourced from the Nestlé Cocoa Plan, which promotes sustainable farming practices and fair trade. Once the raw materials arrive at the production facility, they undergo a series of inspections and tests to verify purity, consistency, and compliance with food safety regulations. This includes spectroscopic analysis for contaminants, moisture content testing, and sensory evaluations conducted by trained professionals. Once approved, the ingredients are stored in temperature-controlled silos and dispensing systems. The flour is kept in airtight storage to prevent contamination, while cocoa and milk powder are maintained under controlled humidity conditions to prevent clumping. Automated feeding systems transport these raw materials to the respective processing units, ensuring precise measurement and consistency in formulation. The first major step in KitKat production is wafer baking. The signature light and crispy wafer layers are created through a precise blending of wheat flour, water, sugar, and vegetable oils. Large industrial mixers, equipped with programmable logic controllers, ensure thorough mixing to produce a smooth and homogeneous batter. Once mixed, the batter is transferred via pressurized pumps to high-speed continuous wafer baking ovens. These ovens feature rotating baking plates that evenly distribute the batter across the surface, forming thin sheets of wafer. The baking plates operate at carefully controlled temperatures, typically around 180 to 200 degrees Celsius, ensuring uniform texture and color. The baked wafer sheets emerge golden brown and crisp, ready for the next stage. To enhance the crispness, the wafer sheets pass through a controlled cooling system. Conveyor belts transport the freshly baked wafers through a cooling tunnel, where calibrated fans gradually reduce the temperature to prevent thermal shock. The cooled wafers are then directed to the trimming and cutting station. Automated guillotine cutters trim the edges of the wafers to achieve uniform dimensions, ensuring consistency across all KitKat bars. Once trimmed, the wafers are transported to the layering station. Here, a fine layer of chocolate cream filling made from a precise blend of cocoa, sugar, and milk powder is evenly spread onto the wafers. Automated depositor machines ensure the filling is applied uniformly, maintaining the right thickness for optimal texture. The layering process continues with additional wafer sheets stacked on top, creating a multi-layered wafer slab. These slabs are then pressed under controlled pressure to bond the layers together without crushing the delicate structure. After layering, the wafer slabs proceed to the cutting stage. High-speed rotary or ultrasonic blade systems slice the large wafer sheets into precise rectangular portions, forming the individual KitKat fingers. Ultrasonic cutting technology is particularly effective in ensuring clean, precise cuts without generating excess crumbs or damaging the layers. The next crucial step is chocolate enrobing. The enrobing process begins with the preparation of molten milk chocolate, which is produced in large conching machines. These machines continuously grind and blend cocoa mass, cocoa butter, sugar, and milk powder, refining the mixture to achieve a smooth, velvety consistency. The conching process, which can last several hours, helps develop the rich, creamy texture and enhances the flavor profile of the chocolate. Once ready, the molten chocolate is fed into enrobing machines, where KitKat fingers pass through a curtain-like flow of chocolate. These enrobers ensure complete coverage, with excess chocolate removed using controlled air jets and vibrating conveyors. To achieve the signature glossy finish, the enrobed bars pass through a tempering unit, which carefully regulates the chocolate's crystallization process. This involves a precise cycle of heating, cooling, and reheating to stabilize the cocoa butter crystals, preventing bloom and ensuring a smooth, even texture. Following enrobing, the chocolate-covered KitKat bars enter a cooling tunnel. This tunnel, equipped with multi-zoned cooling technology, gradually reduces the temperature in stages to solidify the chocolate coating without causing cracks or condensation. The cooling process is carefully monitored using infrared sensors to maintain consistency. Once the chocolate is fully set, the KitKat bars move to the quality control and inspection stations. Advanced vision inspection systems, equipped with high-resolution cameras, scan each bar for defects, such as uneven coating, improper sizing, or misaligned layers. Bars that do not meet quality standards are automatically rejected by robotic sorting arms and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. After passing inspection, the KitKat bars are transported to high-speed wrapping machines. Individual bars are wrapped in foil or plastic film using heat sealing technology, ensuring airtight packaging that preserves freshness. These wrapped bars are then grouped into multi-packs, which are subsequently boxed using robotic case packers. The packaging design is carefully printed with product details, barcodes, and branding elements before final sealing. The packaged KitKat bars are then palletized for distribution. Automated palletizing systems stack the boxes onto pallets in a precise arrangement to optimize space utilization during transportation. These pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for delivery to distribution centers worldwide. The logistics process is carefully coordinated to ensure timely delivery, with real-time tracking systems monitoring shipments from factory to retailer. Throughout the entire production process, extensive quality control measures are in place to uphold product integrity. Each batch undergoes rigorous laboratory testing, including microbiological screening, allergen testing, and texture analysis. Data from all processing stages is logged in automated tracking systems, allowing full traceability and compliance with food safety regulations. While the fundamental principles of KitKat production remain consistent across different manufacturing plants, regional variations may exist to cater to local tastes and preferences. For example, KitKat flavors such as matcha green tea, strawberry, and sake are produced in Japan using specialized formulations. Some factories may also incorporate alternative chocolate blends, varying cocoa content to suit market demands. Nestlé continues to innovate and optimize KitKat production through advancements in automation, sustainability initiatives, and ingredient sourcing. Modern factories are increasingly utilizing AI-driven quality control systems, energy-efficient processing equipment, and eco-friendly packaging solutions to reduce environmental impact. With continuous improvements in manufacturing technology, KitKat remains a global favorite, offering consumers a consistently delightful chocolate experience in every bite. Mars bars, one of the most iconic chocolate confections in the world, are produced in highly sophisticated manufacturing facilities designed to ensure consistency, efficiency, and quality at every step of the process. The production of Mars bars involves multiple intricate stages, from sourcing and processing raw ingredients to forming, enrobing, cooling, and packaging the final product. Each step is meticulously controlled using advanced automation technology and stringent quality control measures to ensure the signature caramel, nougat, and chocolate combination is perfectly replicated in every bar. The process begins with the careful selection of raw ingredients. The main components of a Mars bar include sugar, cocoa mass, cocoa butter, skimmed milk powder, whey powder, palm fat, glucose syrup, lactose, milk fat, and egg whites. These ingredients are sourced from trusted suppliers and undergo rigorous quality assurance checks upon arrival at the factory. Sugar, which plays a crucial role in both the nougat and caramel layers, is stored in large silos, where it is kept dry and free from contamination. Cocoa products, including cocoa mass and cocoa butter, are stored in climate-controlled environments to prevent degradation. Dairy ingredients, such as skimmed milk powder and whey powder, are tested for purity and consistency before use. Once the raw ingredients are approved, the first major stage in Mars bar production is the creation of the nougat layer. Nougat is a key structural component of the bar, providing a soft, chewy texture that contrasts with the caramel and chocolate. The nougat making process begins in large industrial mixing tanks, where a combination of sugar, glucose syrup, and water is heated to create a syrup. This syrup is then aerated using a whipping system, which incorporates fine air bubbles to achieve the desired light and fluffy texture. During this stage, egg whites or hydrolyzed soy protein are added as stabilizers to maintain the nougat's consistency. Once the nougat mixture reaches the proper texture, it is transferred onto a continuous conveyor belt, where it is spread into an even layer. This belt passes through a cooling tunnel to allow the nougat to set before it reaches the next stage of the process. The cooled nougat layer is then precisely cut into rectangular strips using high-speed guillotine cutters. These strips will form the base of each Mars bar. The next step in the process is the caramel layer. The caramel used in Mars bars is created through a controlled cooking process that involves heating sugar, glucose syrup, and milk ingredients to high temperatures. This process requires careful monitoring to achieve the perfect balance of sweetness and viscosity. Industrial batch cookers equipped with automated temperature controls ensure that the caramel reaches the ideal consistency before it is deposited onto the nougat base. The caramel is applied as a continuous sheet over the nougat layer, ensuring even distribution and uniform thickness. Once the caramel is applied, the combined nougat and caramel layers proceed through a controlled cooling tunnel, where the temperature is gradually reduced to allow the caramel to set without becoming too hard or sticky. This ensures that the layers remain cohesive and easy to cut in the next stage of production. After cooling, the layered nougat and caramel sheets are fed into an automated cutting system, which uses precision blades to slice them into individual bar-sized portions. These freshly cut bars are then transported via conveyor belts to the enrobing station, where they receive their final chocolate coating. The enrobing process is a critical step in Mars bar production, as it gives the bars their signature smooth milk chocolate exterior. The chocolate coating is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder, which is carefully tempered to achieve the perfect texture and glossy finish. The tempering process involves heating and cooling the chocolate in a controlled manner to ensure the cocoa butter crystals form a stable structure, preventing fat bloom and ensuring a smooth mouthfeel. At the enrobing station, the cut nougat and caramel bars pass through a curtain-like waterfall of molten chocolate, which fully coats them. Excess chocolate is removed using controlled air jets and vibrating conveyors to ensure an even layer without excessive buildup. Some factories use a two-stage enrobing process, where an initial thin layer of chocolate is applied as a base coat before the final, thicker chocolate layer is added. After enrobing, the chocolate-covered bars enter a multi-zone cooling tunnel, which gradually reduces their temperature in controlled stages. This cooling process allows the chocolate to set properly without developing cracks or a dull surface. The bars emerge from the cooling tunnel with a perfectly set chocolate shell, ready for the final stages of quality control and packaging. Quality control is a fundamental part of Mars bar production, ensuring that only bars meeting strict standards reach consumers. Automated vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, misshapen forms, or inconsistencies in size. Bars that do not meet the required specifications are automatically rejected and sent for reprocessing. Additional quality control measures include weight checks using precision weighing systems, texture analysis, and sensory evaluations conducted by trained specialists. Once the bars pass quality inspection, they proceed to the packaging area, where high-speed wrapping machines individually wrap each bar in foil or plastic film. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and placed into branded cartons, which are sealed and labeled using automated case packing systems. The final step in the process is palletization and distribution. Automated palletizing systems stack the packaged bars onto pallets in a precise arrangement to optimize space utilization during transportation. The pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retail stores and supermarkets worldwide. The entire logistics process is carefully coordinated to ensure timely delivery while maintaining the product's freshness and quality. Throughout the entire manufacturing process, Mars maintains stringent quality control and food safety standards. Each production batch undergoes extensive laboratory testing, including microbial analysis, allergen testing, and moisture content verification. The company also invests in sustainable sourcing initiatives, ensuring that key ingredients such as cocoa and palm oil are responsibly sourced to minimize environmental impact. Different Mars manufacturing facilities may incorporate slight variations in processing techniques based on regional ingredient availability, consumer preferences, or proprietary formulations. Some facilities may use alternative chocolate blends with varying cocoa content to cater to specific markets, while others may modify the nougat formulation for textural differences. Additionally, Mars continuously invests in research and development to improve efficiency, reduce energy consumption, and enhance sustainability in its production processes. With advancements in automation, AI-driven quality control systems, and eco-friendly packaging innovations, the production of Mars bars continues to evolve while maintaining the signature taste and texture that consumers have loved for generations. Twix, one of the world's most beloved chocolate bars, is manufactured using a highly sophisticated and automated process that ensures each bar maintains its signature combination of crunchy biscuit, smooth caramel, and creamy milk chocolate coating. The production of Twix bars occurs in state-of-the-art factories that utilize precision engineering, cutting-edge food processing technology, and rigorous quality control protocols. From the sourcing of raw ingredients to packaging and distribution, every step is carefully orchestrated to guarantee consistency, efficiency, and superior taste. The process begins with the selection and procurement of high-quality raw materials. The key ingredients in Twix bars include wheat flour, sugar, palm oil, cocoa butter, skimmed milk powder, cocoa mass, lactose, whey powder, salt, and emulsifiers. These ingredients are sourced from carefully vetted suppliers who must meet strict food safety and sustainability requirements. For instance, the cocoa used in Twix bars is sourced through Mars' Cocoa for Generations initiative, ensuring ethical sourcing and environmental responsibility. Similarly, the palm oil used in the biscuits and caramel is certified sustainable to reduce environmental impact. Upon arrival at the manufacturing facility, the raw ingredients undergo thorough quality checks before entering the production process. These checks include spectroscopic analysis to detect contaminants, moisture content analysis to ensure freshness, and sensory evaluations to verify taste and aroma. Ingredients that meet the necessary standards are then stored in temperature-controlled silos and storage units to maintain their quality. The first step in the actual production process is the creation of the biscuit base. Twix bars are distinguished by their crunchy, shortbread-like biscuit layer, which requires precise preparation and baking. The process begins in large industrial mixers, where wheat flour, sugar, palm oil, and leavening agents are combined to form a dough. The mixing process is carefully timed to ensure the dough reaches the ideal consistency, firm enough to hold its shape during baking, yet tender enough to create the signature crisp texture. Once the dough is fully mixed, it is transferred to an automated sheeting system. This system rolls the dough into a uniform sheet of the exact thickness required for Twix bars. The sheeted dough then moves to a rotary cutting machine, which stamps out individual biscuit fingers. Each biscuit is precisely cut to ensure uniform size and shape, allowing for seamless assembly in later stages. The cut dough pieces are placed onto conveyor belts and transported into a large industrial baking oven. These ovens operate using a continuous baking system where the biscuit fingers travel through different heat zones that gradually bake them to perfection. The baking temperature is carefully controlled, typically ranging between 180 to 200 degrees Celsius, 356 to 392 degrees Fahrenheit, ensuring that each biscuit is evenly baked to a golden brown. Advanced infrared sensors monitor the biscuits throughout the baking process, ensuring uniformity in color, texture, and moisture content. Once fully baked, the biscuits pass through a cooling tunnel that gradually reduces their temperature, preventing cracking or breakage. Next, the caramel layer is prepared. The caramel used in Twix bars is made from a precise blend of sugar, glucose syrup, milk, and butter. This mixture is heated in large stainless steel batch cookers, where it undergoes controlled caramelization. The temperature and cooking time are crucial in achieving the perfect consistency, thick enough to stay in place on the biscuit, but soft enough to deliver a smooth, chewy texture. Once the caramel reaches the desired consistency, it is transferred to a continuous depositor system. This machine evenly dispenses a uniform layer of caramel onto each biscuit. The caramel application must be carefully controlled to ensure consistency in thickness across all bars. Any inconsistencies could lead to difficulties in chocolate enrobing or affect the final texture. With the caramel applied, the bars move along the conveyor belt to a cooling station, where they pass through a controlled cooling tunnel. This tunnel gradually reduces the temperature of the caramel, allowing it to set properly while maintaining its soft, chewy texture. After cooling, the caramel-coated biscuits are ready for the enrobing process, where they will be covered in rich milk chocolate. The enrobing process is one of the most critical steps in Twix production. The milk chocolate coating is prepared in large conching machines, which continuously grind and refine cocoa mass, cocoa butter, sugar, and milk powder. This process enhances the texture and flavor of the chocolate, ensuring a smooth, creamy consistency. The chocolate is then tempered, a controlled heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering is essential to achieving the signature glossy finish and preventing fat bloom, white streaks that can appear on improperly tempered chocolate. At the enrobing station, the caramel-topped biscuits pass through a continuous chocolate waterfall. This ensures that each bar is fully coated in an even layer of chocolate. Any excess chocolate is removed using controlled air jets and vibrating conveyors, which help distribute the chocolate evenly without excessive buildup. Some factories employ a two-stage enrobing process, where a thin base coat of chocolate is applied first to ensure better adhesion before the final, thicker chocolate layer is added. Once the bars are coated, they enter a multi-zone cooling tunnel. This tunnel is divided into different temperature zones that gradually reduce the temperature, allowing the chocolate to set perfectly without cracking or becoming dull. The bars emerge from the cooling tunnel with a firm, glossy chocolate coating, ready for the next stage of production. Quality control is a top priority at every stage of Twix production. After cooling, the bars pass through a series of automated inspection systems. High-speed vision cameras scan each bar for inconsistencies in chocolate coating, caramel distribution, and overall shape. Any bars that do not meet specifications are automatically rejected and sent for reprocessing. In addition to visual inspections, quality control teams conduct random weight checks, moisture analysis, and sensory evaluations to ensure that each batch meets Mars's stringent quality standards. Once the bars have passed inspection, they move to the packaging stage. Twix bars are individually wrapped using high-speed horizontal flow wrapping machines. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs, which are sealed in branded cartons using automated case packing systems. After packaging, the final step in the process is palletization and distribution. Robotic palletizing systems stack the packaged bars onto pallets in precise arrangements, optimizing space for transport. The pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Mars utilizes an advanced logistics network to ensure efficient delivery while maintaining product freshness. Throughout the entire production process, Mars adheres to strict food safety and sustainability standards. Each batch undergoes rigorous laboratory testing, including microbiological analysis, allergen testing, and texture verification. The company also invests in eco-friendly initiatives, such as reducing energy consumption in manufacturing and using recyclable packaging materials. Different Mars factories may employ slight variations in processing techniques based on regional ingredient availability and consumer preferences. For example, some regions may use alternative chocolate formulations with varying cocoa content, while others may adjust the caramel consistency based on market preferences. Additionally, limited edition Twix flavors, such as Twix white chocolate and Twix peanut butter, require modifications in ingredient formulation and processing techniques. As consumer demand for innovative flavors and healthier options grows, Mars continues to invest in research and development to improve Twix production. Recent advancements in AI-driven quality control, robotic automation, and sustainable ingredient sourcing are shaping the future of Twix manufacturing. Despite these innovations, the core principles of precision, consistency, and quality remain unchanged, ensuring that every Twix bar delivers the signature, crunchy, chewy, and chocolatey experience that consumers love. The making of a Hershey's chocolate bar is a complex, highly automated process that combines tradition with cutting-edge technology. From sourcing high-quality cocoa beans to wrapping the final product, every step is optimized for efficiency, consistency, and taste. The journey of a Hershey's bar begins with the careful selection of raw ingredients sourced from around the world. Cocoa, sugar, milk, and other ingredients are carefully tested to ensure they meet the company's high standards before they are transformed into the iconic chocolate bars that have been loved for generations. At the heart of every Hershey's chocolate bar is cocoa. The company sources its cocoa beans primarily from Ghana, Côte d'Ivoire, and Ecuador, regions known for producing high-quality beans with robust flavor profiles. Cocoa farmers in these areas harvest the ripe pods, extract the cocoa beans, and allow them to ferment for several days to develop their characteristic chocolatey taste. Once dried, the beans are shipped to Hershey's production facilities, where they undergo rigorous quality checks. Each shipment is tested for moisture content, flavor consistency, and the absence of contaminants. Only the highest quality beans make it through this stringent selection process. Once approved, the cocoa beans are sent to the roasting stage. Large industrial roasters expose the beans to carefully controlled heat, typically between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit, depending on the desired flavor profile. The roasting process is essential for developing the deep, complex flavors of chocolate. Different roasting profiles are used depending on whether the beans will be used for milk chocolate, dark chocolate, or other specialty products. After roasting, the cocoa beans enter the winnowing process. Specialized machinery cracks the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both the cocoa solids and cocoa butter needed for chocolate production. The nibs are then ground into a thick, dark paste known as chocolate liquor, which contains no alcohol despite its name. This chocolate liquor is the base for all Hershey's chocolate products. For Hershey's classic milk chocolate bars, chocolate liquor is combined with sugar, milk, and cocoa butter. The milk used in Hershey's chocolate is a key ingredient that gives it its distinctive taste. Unlike many European chocolates that use powdered or condensed milk, Hershey's uses fresh milk sourced from dairy farms in Pennsylvania and surrounding states. The milk is pasteurized and condensed before being blended with sugar to create a sweet, creamy base. The next stage in the process is refining. The chocolate mixture is run through a series of steel rollers that grind the particles to an ultra-fine consistency. This refining process is crucial for creating a smooth, melt-in-your-mouth texture. The finer the particles, the smoother the final chocolate will be. Once refined, the chocolate undergoes conching, a critical process that enhances flavor and texture. Conching machines, which resemble large industrial mixers, continuously stir the chocolate at controlled temperatures for several hours. This process aerates the chocolate, allowing unwanted acidic compounds to evaporate while enhancing its creamy mouthfeel. Hershey's uses a proprietary conching method that contributes to its signature flavor, which has a slightly tangy undertone due to controlled acidity in the milk. After conching, the chocolate moves to the tempering stage. Tempering is the process of heating and cooling chocolate in a precise manner to stabilize the cocoa butter crystals. Proper tempering ensures that Hershey's bars have a glossy finish, a firm snap, and a long shelf life. If the chocolate were not tempered correctly, it could develop fat bloom, a whitish streaking effect caused by unstable cocoa butter. Now, the tempered chocolate is ready for molding. Automated machines pour precise amounts of liquid chocolate into bar-shaped molds, which are then vibrated to remove air bubbles and ensure even distribution. The molds travel along a conveyor system into a cooling tunnel, where the chocolate solidifies into its final shape. Once cooled, the bars are ejected from their molds and transported via conveyor belts to the packaging area. Here, high-speed wrapping machines encase each bar in foil and branded paper sleeves, protecting the chocolate from moisture and light while ensuring a fresh, appealing presentation. Throughout the entire process, strict quality control measures are in place. High-resolution vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or size inconsistencies. Bars that do not meet specifications are automatically rejected and sent for reprocessing. Additionally, random sensory evaluations are conducted by trained taste testers to ensure that the flavor, texture, and overall quality remain consistent. Once packaged, the final step is palletization and distribution. Automated robotic arms stack the packaged bars onto pallets, which are then shrink-wrapped for stability. These pallets are loaded onto temperature-controlled trucks and shipped to retailers worldwide. Hershey's operates an advanced logistics network that ensures timely delivery while maintaining product freshness. The entire manufacturing process is designed for efficiency, consistency, and sustainability. Hershey's continues to invest in eco-friendly initiatives, such as reducing water and energy consumption in production, using ethically sourced cocoa, and optimizing packaging materials to minimize waste. Different Hershey's factories may employ slight variations in processing techniques based on regional preferences and ingredient availability. Additionally, specialty products like Hershey's cookies and cream bars or Hershey's dark chocolate require modifications in ingredient formulation and processing times. As the chocolate industry continues to evolve, Hershey's remains at the forefront of innovation, combining tradition with advanced manufacturing techniques to produce its iconic chocolate bars. Through precision engineering, strict quality control, and a commitment to excellence, Hershey's ensures that every bar delivers the same beloved taste that generations have enjoyed. The making of Toblerone, the iconic triangular chocolate bar, is a masterclass in precision engineering, premium ingredient selection, and automated manufacturing processes. Unlike conventional chocolate bars, Toblerone stands out for its distinctive shape, rich Swiss milk chocolate, and the inclusion of honey and almond nougat. Every step, from sourcing the finest ingredients to molding the signature peaks, is meticulously controlled to ensure quality, consistency, and adherence to the Swiss chocolate-making tradition. The process begins with sourcing high-quality ingredients. Toblerone's signature flavor comes from its carefully selected components: Swiss milk, sugar, cocoa mass, cocoa butter, honey, almonds, and egg whites. The milk, sourced from Swiss dairy farms, is a critical ingredient that contributes to the creamy texture. The cocoa is sourced from sustainable farms in Ghana and Ecuador, where beans are hand-harvested, fermented, and dried under strict quality control measures. Almonds are procured from select suppliers, ensuring they meet the required standards of size, flavor, and crunch. The honey, a key component that adds a subtle sweetness, is sourced from European beekeepers specializing in high-quality aromatic varieties. Once the ingredients arrive at the production facility, they undergo rigorous quality checks. Advanced spectroscopic analysis, moisture content testing, and flavor profiling ensure that each ingredient meets the brand's high standards. The cocoa beans are then roasted at carefully controlled temperatures to develop their deep, complex flavor. Different roasting profiles are used depending on whether the beans will be used for Toblerone's milk, dark, or white chocolate variations. After roasting, the cocoa beans move to the winnowing stage, where high-powered machinery cracks them open and removes the husks. The remaining cocoa nibs, which contain the essence of the chocolate, are then finely ground into a thick, rich paste known as chocolate liquor. This forms the base of Toblerone's chocolate. The chocolate liquor is blended with sugar, cocoa butter, and Swiss milk powder to create the signature, smooth and creamy chocolate mixture. The next step in the process is refining. The chocolate mixture passes through a series of heavy-duty steel rollers that break down the particles to an ultra-fine consistency. This is crucial in achieving the signature melt-in-your-mouth texture. The refining process also helps blend the ingredients evenly, ensuring a perfectly smooth mixture. Following refining, the chocolate undergoes conching, a process that enhances its texture and flavor. Large conching machines continuously mix, aerate, and heat the chocolate for several hours, allowing volatile acids to evaporate and the flavors to develop fully. Toblerone's conching process is fine-tuned to create a silky texture and a well-rounded, rich taste. Meanwhile, the honey and almond nougat mixture is prepared in a separate area of the factory. Sugar, honey, and egg whites are heated and aerated to create a light, chewy nougat. Almonds, which have been roasted to bring out their nutty aroma, are chopped into small pieces and folded into the nougat mixture. The nougat is then cooled and ground into fine pieces before being incorporated into the chocolate. Once the chocolate has completed the conching process, the finely ground nougat mixture is carefully folded into it, ensuring even distribution. This step is crucial in maintaining the signature texture and taste of Toblerone. With the chocolate and nougat mixture fully blended, the next stage is tempering. Tempering is a precise process of heating and cooling chocolate in a controlled manner to stabilize the cocoa butter crystals. Proper tempering ensures that the chocolate has a glossy finish, a firm snap, and a smooth texture. Toblerone's tempering process is carefully calibrated to achieve the ideal consistency before molding. Molding is where Toblerone's iconic shape comes to life. The tempered chocolate is poured into custom-designed triangular molds that give the bar its distinctive peaks. The molds are gently vibrated to remove air bubbles and ensure even distribution of the chocolate. After molding, the bars pass through a cooling tunnel, where they are gradually cooled to allow the chocolate to set perfectly without cracks or imperfections. Once solidified, the bars are removed from the molds and transported to the quality control station. Each bar is inspected using high-resolution vision cameras, which detect any inconsistencies in shape, texture, or coating. Automated sorting systems remove any defective bars, ensuring that only perfectly shaped Toblerone bars proceed to packaging. The packaging process is designed to maintain the freshness and integrity of the chocolate. Toblerone bars are individually wrapped in foil to protect them from moisture and light, then placed into the iconic triangular cardboard cartons. High-speed packaging machines fold and seal the cartons with precision, ensuring that the bars remain securely enclosed. Following packaging, the bars are palletized using robotic systems, stacked carefully for stability during transport. These pallets are shrink-wrapped and loaded onto trucks for distribution to markets around the world. Temperature-controlled logistics ensure that the chocolate remains in perfect condition during transit. Throughout the entire manufacturing process, Toblerone maintains strict quality control measures. Each batch undergoes laboratory testing, including texture analysis, microbial screening, and taste assessments conducted by trained specialists. Data is continuously logged in automated tracking systems, allowing for full traceability of every Toblerone bar produced. Different Toblerone manufacturing facilities may employ slight variations in processing techniques depending on regional ingredient availability and market preferences. Specialty additions, such as Toblerone white chocolate or Toblerone dark, require slight modifications in ingredient formulations and processing steps. As consumer preferences evolve, Toblerone continues to innovate while maintaining the brand's heritage of Swiss chocolate craftsmanship. Investments in sustainable cocoa sourcing, eco-friendly packaging solutions, and advanced automation ensure that Toblerone remains a global favorite while reducing its environmental footprint. Through precision engineering, time-honored techniques, and a commitment to quality, every Toblerone bar delivers the signature taste and texture that chocolate lovers around the world cherish. The production of Snickers, one of the world's most popular chocolate bars, is a highly automated and meticulously controlled process designed for efficiency, consistency, and large-scale output. With its signature combination of nougat, caramel, peanuts, and milk chocolate, Snickers is produced in state-of-the-art facilities that use cutting-edge food processing technology, ensuring that every bar meets the brand's high-quality standards. From sourcing the finest raw ingredients to packaging and distribution, every step is optimized to deliver the same taste, texture, and satisfaction in every bite. The journey of a Snickers bar begins with the careful selection of raw materials. The main components include sugar, peanuts, milk powder, cocoa mass, cocoa butter, palm oil, glucose syrup, egg whites, and emulsifiers. These ingredients are sourced from carefully vetted suppliers, ensuring compliance with strict food safety and sustainability standards. Mars, the company behind Snickers, prioritizes responsible ingredient sourcing, ensuring that cocoa is ethically obtained through its Cocoa for Generations program, which promotes fair labor practices and sustainable farming methods. Peanuts, another crucial ingredient, are primarily sourced from the United States, where they are grown under controlled conditions to maintain size, flavor, and crunch. Once the ingredients arrive at the manufacturing facility, they undergo a rigorous quality control process. Each batch is tested for moisture content, purity, and potential contaminants. Peanuts, in particular, go through an additional inspection phase, where they are sorted by size and quality. High-speed optical sorting machines remove any defective or discolored peanuts, ensuring that only the best nuts make it into Snickers bars. The first major step in the Snickers production process is creating the nougat base. Nougat provides the chewy texture that forms the foundation of the bar. It is made by combining sugar, corn syrup, and water, which are heated in large industrial cooking vats to create a syrup. This syrup is then aerated using high-powered whipping machines, which incorporate fine air bubbles, giving the nougat its characteristic light and chewy texture. Egg whites or soy protein are added as stabilizers to help maintain consistency. Once aerated, the nougat is spread onto a moving conveyor belt in a continuous sheet, where it is allowed to cool and set. This process is carefully controlled to prevent the nougat from becoming too hard or too soft. Automated guillotine cutters then slice the nougat sheet into uniform rectangular portions, ensuring that each piece is the exact size required for Snickers bars. Next comes the caramel layer. The caramel in Snickers is made from a blend of sugar, glucose syrup, milk, and butter, which is heated in large stainless steel batch cookers. The temperature is carefully monitored to achieve the perfect viscosity, thick enough to hold its shape, but soft enough to provide a smooth, chewy texture. Once cooked to perfection, the caramel is poured in a controlled stream onto the nougat base. The caramel-covered nougat passes through a cooling tunnel, where it sets just enough to be firm, but still pliable. Now it's time to add the peanuts. Before being incorporated into the bars, the peanuts are roasted in industrial ovens to enhance their flavor and crunch. After roasting, they are cooled and evenly distributed over the caramel layer using precision peanut dispensers. These machines ensure that each bar receives the right amount of peanuts, maintaining uniformity across all Snickers bars. Once the peanuts are in place, the layered nougat, caramel, and peanut sheet moves to the cutting stage. High-speed rotary blades slice the continuous sheet into individual bar-sized portions. Each cut must be precise, ensuring that the caramel and nougat layers remain intact while maintaining a consistent size. The next critical step is chocolate enrobing. The milk chocolate coating used for Snickers bars is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder. This mixture is refined and conched in large machines that continuously grind the chocolate to achieve a smooth texture. The chocolate is then tempered, a process that involves controlled heating and cooling to stabilize the cocoa butter crystals. Proper tempering ensures a glossy finish and prevents fat bloom, which can cause chocolate to develop a dull appearance. At the enrobing station, the cut bars pass through a waterfall of liquid milk chocolate, fully coating them. Excess chocolate is removed using controlled air jets and vibrating conveyors, ensuring an even layer without excessive buildup. Some factories use a two-stage enrobing process, where a thin base coat of chocolate is applied first to create a stable foundation before the final. Thicker chocolate layer is added. After enrobing, the bars enter a multi-zone cooling tunnel. This tunnel gradually lowers the temperature in controlled stages, allowing the chocolate to set properly without developing cracks or dull spots. Once fully cooled, the Snickers bars emerge with a perfectly solidified chocolate coating, ready for quality inspection. Quality control is a critical component of Snickers production. Each bar undergoes a series of automated inspections to ensure that it meets strict specifications. High-speed vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, improper size, or misshapen layers. Any bars that do not meet the required standards are automatically rejected and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. Once the bars have passed inspection, they move to the packaging stage. Snickers bars are individually wrapped in plastic film using high-speed horizontal flow wrapping machines. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and packed into branded cartons using automated case packers. The final step in the process is palletization and distribution. Automated systems stack the package cartons onto pallets in precise formations, optimizing space for transport. These pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Snickers bars are shipped to over 70 countries, requiring an advanced logistics network to ensure that they arrive fresh and in perfect condition. Throughout the entire production process, Mars maintains stringent food safety and sustainability practices. Each batch undergoes extensive laboratory testing, including microbiological screening, allergen testing, and texture verification. The company also invests in sustainable ingredient sourcing, reducing its environmental footprint through energy-efficient manufacturing processes and eco-friendly packaging solutions. Different Snickers manufacturing facilities may employ slight variations in processing techniques based on regional ingredient availability and consumer preferences. For example, some regions may use alternative chocolate blends with varying cocoa content, while others may modify the nougat or caramel consistency based on market demands. Additionally, special edition Snickers bars, such as Snickers almond or Snickers peanut butter, require modifications in ingredient formulation and production methods. As consumer preferences evolve, Mars continues to innovate while maintaining the classic Snickers taste and texture. Advancements in automation, AI-driven quality control, and sustainable manufacturing practices are shaping the future of Snickers production. Despite these innovations, the fundamental principles of precision, consistency, and quality remain unchanged, ensuring that every Snickers bar delivers the same delicious combination of chewy nougat, gooey caramel, crunchy peanuts, and smooth milk chocolate that has made it a favorite among chocolate lovers worldwide. The production of Tony's Chocolonely chocolate bars is a carefully designed process that emphasizes ethical sourcing, sustainability, and high-quality chocolate-making techniques. Unlike traditional chocolate brands, Tony's Chocolonely is dedicated to creating a slave-free chocolate industry, ensuring that every step in the supply chain is transparent and fair. From sourcing cocoa beans from cooperatives in West Africa to molding and packaging the final bars, the production process is a seamless blend of traditional craftsmanship and modern automation. The journey of a Tony's Chocolonely bar begins with cocoa sourcing. The company partners with cooperatives in Ghana and Côte d'Ivoire, regions that are known for cocoa production, but also face significant challenges related to child labor and unfair wages. Tony's Chocolonely implements direct trade practices, paying a premium for cocoa and providing additional support to farmers through training programs and financial resources. This ensures that the beans are ethically sourced while maintaining a high standard of quality. Once harvested, the cocoa beans go through a meticulous post-harvest process. Farmers ferment the beans for several days, a crucial step that develops the deep, complex flavors needed for premium chocolate. After fermentation, the beans are spread out under the sun to dry, reducing moisture content and preventing mold growth. When dried to the appropriate level, the beans are packed into jute sacks and shipped to Tony's Chocolonely's processing facilities. Upon arrival at the factory, the beans undergo rigorous quality control checks. Samples from each shipment are tested for moisture levels, flavor consistency, and potential contaminants. Beans that pass inspection are stored in climate-controlled silos to maintain freshness before entering the production line. The first step in the chocolate making process is roasting. Large industrial roasting machines heat the beans at precise temperatures, usually between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit. This process enhances the natural chocolate flavors and eliminates unwanted bitterness. The roasting time and temperature depend on the type of chocolate being produced. Dark chocolate requires a slightly longer roasting process than milk chocolate to develop its rich, bold flavors. Once roasted, the beans enter the winnowing process. A specialized machine cracks open the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both cocoa solids and cocoa butter, the essential components of chocolate. The nibs are then ground into a thick, smooth paste known as chocolate liquor. This process, carried out by industrial grinders, reduces the particle size of the nibs, creating a velvety consistency. At this stage, different chocolate variations begin to take shape. For Tony's Chocolonely's milk chocolate bars, the chocolate liquor is combined with sugar, milk powder, and additional cocoa butter to create a creamy texture. For dark chocolate, higher cocoa percentages are used with less sugar and no milk. The next step in the process is refining. The chocolate mixture is passed through heavy-duty steel rollers that grind the ingredients into ultra-fine particles. This step is crucial for achieving the smooth texture that defines high-quality chocolate. The finer the particles, the better the melt-in-your-mouth experience. Following refining, the chocolate undergoes conching, a process that enhances both texture and flavor. Large conching machines continuously mix and aerate the chocolate for several hours, allowing any residual acidity to evaporate while intensifying the chocolate's richness. The conching time varies depending on the desired flavor profile. Longer conching results in a smoother, more developed taste. After conching, the chocolate is tempered, a precise heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering ensures that Tony's Chocolonely bars have a glossy finish, a satisfying snap when broken, and a long shelf life without developing fat bloom, the white streaks that can appear on improperly tempered chocolate. Once tempered, the liquid chocolate is ready for molding. Unlike most chocolate bars, Tony's Chocolonely bars are intentionally molded in an uneven pattern, symbolizing the unequal distribution of wealth in the chocolate industry. Automated machines pour precise amounts of chocolate into these custom-designed molds, which are then gently vibrated to remove air bubbles and ensure even distribution. The molds are then transferred to a cooling tunnel, where the chocolate gradually solidifies under controlled temperatures. This process prevents the bars from developing surface defects and ensures that they retain their perfect shape. Once the chocolate has fully set, the bars are ejected from the molds and sent to the quality control station. High-speed vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or uneven texture. Any bars that do not meet the required standards are removed from the production line and either reprocessed or discarded. After passing quality checks, the bars move to the packaging stage. Tony's Chocolonely uses brightly colored, easily recognizable wrappers, each featuring bold typography and branding. The packaging process is fully automated, with high-speed wrapping machines, sealing each bar in foil and paper to protect it from moisture and contamination. The wrapped bars are then packed into cartons using robotic case packers. The final step in the process is palletization and distribution. Automated robotic systems stack the packaged bars onto pallets in a precise arrangement, optimizing space for transport. It all starts with the cocoa bean, the essential ingredient that gives chocolate its signature taste. Cocoa trees grow in the tropical regions of West Africa, South America, and Southeast Asia, where warm temperatures and high humidity create the perfect environment for cacao cultivation. Farmers carefully harvest ripe cocoa pods, slicing them open to extract the cocoa beans nestled inside. These beans are then piled into large heaps or wooden boxes, where they undergo fermentation, a crucial process that develops the deep, complex chocolate flavors. Over several days, the beans are stirred occasionally, allowing natural yeast and bacteria to work their magic. The result is a transformation from bitter, raw cocoa to something much closer to the chocolate taste that will eventually be refined and perfected in Hershey's factories. Once fermentation is complete, the cocoa beans are spread out under the sun to dry. Farmers rake them periodically to ensure even drying, preventing mold growth and preserving the beans' quality. This drying process can take up to a week, depending on weather conditions. When fully dried, the beans are packed into burlap sacks and shipped across the world to Hershey's chocolate production facilities. The journey from farm to factory is carefully monitored, as the quality of the beans at this stage will significantly influence the final product's taste and texture. Upon arrival at the Hershey factory, the cocoa beans go through a strict quality control process. They are first inspected for size, color, and overall condition. Any beans that do not meet the company's rigorous standards are removed from the batch. Next, the beans are thoroughly cleaned to remove any dust, dirt, or foreign matter that may have accumulated during transport. High-powered air jets and mechanical sifters separate unwanted debris, ensuring that only pure cocoa beans proceed to the next stage. Once cleaned, the cocoa beans move into the roasting phase. Roasting is one of the most important steps in chocolate production, as it intensifies the flavor and brings out the rich, aromatic notes associated with Hershey's signature taste. The beans are poured into large rotating drum roasters, where they are exposed to controlled heat for a specific duration. The precise temperature and roasting time are carefully calibrated based on the desired flavor profile. As the beans roast, their moisture content decreases, and chemical changes occur within the beans, developing the characteristic chocolatey taste. The air inside the roasters is constantly circulated to ensure even roasting, and sensors monitor the temperature to maintain consistency. Once the beans have been roasted to perfection, they are transferred to the winnowing machines. Here, the beans are cracked open, breaking them into smaller fragments called nibs. The outer shells, which are no longer needed, are blown away using air currents, leaving only the rich, flavorful cocoa nibs behind. These nibs contain the essence of chocolate, and they will soon be transformed into a smooth, creamy liquid that serves as the foundation for Hershey's chocolate bars. Meanwhile, another critical ingredient in Hershey's chocolate is being prepared: milk. One of the distinguishing features of Hershey's chocolate is its unique milk treatment process, which contributes to its recognizable flavor. Fresh milk is sourced from dairy farms located near the Hershey factory to ensure freshness. Upon arrival, the milk undergoes pasteurization, a heating process that eliminates harmful bacteria while preserving its nutritional qualities. The milk is then condensed and mixed with sugar, creating a rich, sweetened milk base that will later be combined with the cocoa ingredients. As the cocoa nibs continue their transformation, they are sent to grinding machines, where they are crushed into a thick, liquid paste known as chocolate liquor. Despite the name, chocolate liquor contains no alcohol. It is simply the finely ground form of cocoa solids suspended in cocoa butter. The grinding process generates heat, which helps break down the cocoa particles even further, creating a smooth consistency. The quality of this chocolate liquor is crucial, as it will determine the texture and taste of the final chocolate product. Once the chocolate liquor is ready, it is blended with the sweetened condensed milk mixture, along with additional cocoa butter and sugar. These ingredients come together in large industrial mixers, where they are thoroughly blended to create a uniform chocolate mixture. The goal at this stage is to ensure even distribution of flavors, so the chocolate undergoes multiple rounds of mixing and refining. The refining process is carried out using heavy steel rollers, which reduce the particle size of the chocolate to an ultra-fine consistency. This step is essential for achieving the smooth texture that Hershey's chocolate bars are known for. After refining, the chocolate mixture moves into the conching phase, a process named after the shell-like shape of the original conching machines. Conching involves continuously churning and aerating the chocolate for several hours, helping to develop a silky texture and deepening the flavor. The friction generated by the conching machines warms the chocolate slightly, allowing undesirable acidity and bitterness to dissipate while enhancing the overall creaminess. Hershey's carefully controls the conching process to achieve a balance of flavors that has remained consistent for over a century. Once conching is complete, the chocolate is not yet ready to be molded into bars. It must first undergo tempering. Tempering is a delicate process that involves heating and cooling the chocolate in a precise manner to stabilize the cocoa butter crystals. If chocolate is not properly tempered, it can develop a dull appearance, a grainy texture, or white streaks known as bloom. To prevent this, Hershey's employs advanced tempering machines that carefully regulate the temperature changes, ensuring that the chocolate maintains a glossy finish and a firm, satisfying snap when broken. With the chocolate now perfectly tempered, it is ready to be molded into the iconic Hershey's chocolate bar shape. Liquid chocolate flows into custom-designed molds that feature the signature rectangular segments, each embossed with the Hershey's logo. These molds travel along a conveyor belt through a cooling tunnel, where the chocolate gradually solidifies. The cooling process is precisely controlled to ensure even crystallization, which contributes to the final bar's smooth texture and structure. Once the chocolate has fully set, the bars are carefully removed from the molds and inspected for any imperfections. While the chocolate bars are being formed, the packaging materials are also being prepared. Hershey's chocolate bars are wrapped in a combination of foil and paper, a packaging style that has remained largely unchanged for decades. The foil wrapping helps protect the chocolate from moisture and light, preserving its freshness and preventing it from developing off flavors. The outer paper wrapper, printed with the familiar Hershey's branding, serves as both an aesthetic and informational component, providing details about the product while reinforcing the brand's legacy. As the tempered chocolate flows through the production line, it is maintained at an exact temperature to prevent premature setting. Hershey's factories employ state-of-the-art computerized systems that regulate every aspect of the chocolate's movement, ensuring that the liquid chocolate maintains the ideal viscosity. If the chocolate is too thick, it may not fill the molds evenly. If it is too thin, it may not develop the proper texture once solidified. To maintain this delicate balance, specialized flow control pumps continuously circulate the chocolate through insulated pipes that keep it warm and fluid until the exact moment it is deposited into the molds. The molds themselves are engineered with extreme precision to create the uniform shape and smooth surface that Hershey's chocolate bars are known for. Each mold is made from food-grade polycarbonate material, designed to withstand repeated use while maintaining an ultra-smooth interior that ensures the chocolate releases cleanly once set. These molds travel along a high-speed conveyor belt system, positioned beneath nozzles that dispense the precise amount of liquid chocolate needed to form each bar. Advanced sensors monitor the filling process, making real-time adjustments to ensure that every mold receives an identical amount of chocolate. Once the molds are filled, the next critical step in the process is vibration. The conveyor belt moves the freshly filled molds to a specialized vibrating platform, which gently shakes them at a controlled frequency. This step serves two important purposes. First, it helps remove any trapped air bubbles that could create holes or uneven textures in the final product. Second, it ensures that the chocolate settles evenly within the mold, creating a smooth and uniform appearance. Even the slightest inconsistency in this stage could lead to defects in the bars, so Hershey's quality control team continuously monitors the process to maintain consistency. After vibration, the molds enter a cooling tunnel, a long temperature-controlled chamber that gradually reduces the chocolate's temperature to encourage proper crystallization. This step is crucial for achieving the perfect texture and preventing unwanted fat bloom, which can occur when cocoa butter crystallizes improperly, resulting in a white, powdery appearance on the surface of the chocolate. The cooling tunnel is divided into multiple temperature zones, allowing the chocolate to solidify gradually rather than cooling too quickly, which could cause structural weaknesses or affect the snap of the final bar. As the chocolate sets, it undergoes another round of automated inspection to detect any irregularities. high-resolution cameras and laser scanners analyze each mold, checking for inconsistencies in shape, texture, or surface quality. Any bars that do not meet Hershey's exacting standards are rejected and sent back for remelting, ensuring that no chocolate goes to waste. Once the bars pass inspection, they are gently removed from the molds using an automated demolding system. A combination of slight flexing and compressed air helps separate the bars from the molds without damaging their delicate structure. Now that the chocolate bars have taken their final shape, they must be prepared for packaging. Hershey's packaging process is one of the most sophisticated in the confectionery industry, designed to ensure that each bar remains fresh and protected from environmental factors such as moisture, temperature fluctuations, and physical damage. The first step in packaging involves a high-speed wrapping machine that envelopes each bar in a layer of aluminum foil. This foil serves as a crucial barrier against light and oxygen, both of which can negatively impact the flavor and quality of the chocolate over time. Once the bars are wrapped in foil, they move to the next stage, where the outer paper wrapper is applied. Hershey's iconic packaging, with its bold brown and white branding, is instantly recognizable and has remained largely unchanged for decades. The wrapping machine applies a thin bead of adhesive to secure the paper wrapper in place, ensuring that it remains tightly sealed around the foil-covered chocolate bar. Automated sensors check each wrapped bar for proper alignment, rejecting any that do not meet the strict packaging criteria. With individual bars now fully wrapped, the next step is bundling them into larger packs. Depending on the intended retail format, Hershey's chocolate bars may be packaged as single units, multi-packs, or larger bulk boxes for wholesale distribution. Robotic arms carefully arrange the wrapped bars into predetermined configurations, stacking them into cardboard trays or shrink-wrapped bundles. For multi-packs, additional layers of protective film are applied to keep the bars securely together, preventing shifting during transportation. As the packaged chocolate bars move down the production line, they are assigned a unique batch code and expiration date, which are printed onto each wrapper using high-speed inkjet printers. This information is essential for inventory tracking, ensuring that products are rotated properly in warehouses and retail stores. It also allows Hershey's quality control team to trace any potential issues back to a specific production batch if necessary. Once all packaging steps are complete, the finished Hershey's chocolate bars are sent through final inspection before being prepared for shipment. Automated weight sensors check each package to ensure that no product is missing or underweight. Any deviations from the standard weight result in the package being removed from the line for manual inspection. After passing this final quality check, the bars are packed into large shipping cartons, which are sealed and labeled for distribution. The shipping process is a carefully orchestrated operation designed to maintain the integrity of the chocolate during transit. Hershey's distribution centers are equipped with climate-controlled storage areas, ensuring that chocolate is kept at an optimal temperature before being shipped to retailers worldwide. The pallets of chocolate bars are loaded onto refrigerated trucks, which maintain a consistent temperature to prevent melting or fat bloom. During summer months or in regions with particularly hot climates, additional measures are taken, such as using insulated packaging to further protect the chocolate from heat exposure. From the distribution centers, Hershey's chocolate bars are shipped to grocery stores, convenience stores, vending machines, and online retailers. The entire process, from sourcing cocoa beans to the moment a consumer unwraps a bar, is the result of years of expertise, precise engineering, and a deep commitment to quality. Hershey's has spent over a century refining its production methods, leveraging cutting-edge technology while preserving the craftsmanship that has made its chocolate a household favorite. Even after reaching store shelves, Hershey's continues to monitor product freshness through a network of distributors and retail partners. Inventory rotation practices ensure that consumers always receive the freshest possible product, with older stock being sold before newer shipments are placed on shelves. The brand's commitment to quality extends beyond just manufacturing. It includes every aspect of the supply chain, from sourcing raw ingredients to delivering the final product into the hands of consumers. As the packaged chocolate bars leave the production line, they move through an automated sorting system that directs them to the correct pallets for shipment. Robotic arms, programmed with artificial intelligence and real-time scanning capabilities, ensure that each batch is assigned to the right destination. Whether the chocolate bars are heading to domestic supermarkets, international retailers, or specialized distributors, each shipment is meticulously tracked using barcode scanning and digital inventory management systems. Hershey's has invested heavily in supply chain optimization, integrating real-time data analytics to monitor product flow, track expiration dates, and prevent overstocking or shortages. The process of transporting chocolate requires specific environmental controls. Hershey's distribution centers are equipped with temperature-controlled storage facilities to prevent the chocolate from being exposed to excessive heat or humidity. If chocolate bars are stored in less than ideal conditions, the risk of bloom increases. Fat bloom, the most common issue, occurs when the cocoa butter in the chocolate migrates to the surface, creating a dull, whitish coating. Sugar bloom, on the other hand, happens when moisture causes sugar crystals to form on the surface of the chocolate, resulting in a rough texture. While neither of these phenomena makes the chocolate unsafe to eat, they can negatively impact consumer perception and overall product quality. To prevent these issues, Hershey's carefully maintained storage temperatures between 65 degrees Fahrenheit and 70 degrees Fahrenheit, ensuring that the chocolate remains in optimal condition before it reaches retailers. Once the chocolate bars are loaded onto trucks, their journey continues. Hershey's logistics team coordinates shipments using a combination of ground transportation, air freight, and sea freight, depending on the destination. Domestic shipments typically travel via temperature-controlled trucks, while international shipments require specialized shipping containers equipped with insulation and climate control technology. Each step of transportation is monitored to ensure that the chocolate remains in a stable environment, preventing any degradation in quality. At retail distribution centers, Hershey's chocolate bars are unloaded and sorted based on regional demand. Large grocery chains and supermarkets often have automated warehouse systems that use conveyor belts and robotic picking technology to distribute inventory efficiently. Hershey's works closely with retailers to ensure that the product is stocked properly, preventing situations where chocolate sits in storage too long before being placed on shelves. This level of coordination ensures that customers receive the freshest possible product. Inside stores, Hershey's chocolate bars are positioned strategically to maximize sales. The company's marketing and sales teams work with retailers to determine optimal placement, typically near checkout aisles, in candy sections, and in promotional display stands designed to attract impulse buyers. Hershey's has spent years researching consumer behavior, using data-driven insights to refine its approach to in-store merchandising. Seasonal variations such as Halloween, Christmas, and Valentine's Day bring about limited edition packaging and themed chocolate products that are prominently displayed to boost sales during peak shopping periods. While the chocolate bars are now readily available for purchase, Hershey's commitment to quality control does not stop at the point of sale. The company maintains a rigorous consumer feedback system, allowing customers to report any quality concerns or irregularities. If a batch of chocolate bars is found to have any defects, Hershey's can trace the issue back to a specific production lot using the batch codes printed on each wrapper. This traceability ensures that any necessary corrective actions, such as recalls or reformulation, can be implemented quickly and efficiently. Hershey's also invests heavily in food safety measures, adhering to strict regulatory standards set by organizations such as the US Food and Drug Administration, FDA, the Food Safety Modernization Act, FSMA, and global food safety initiatives. In addition to routine quality checks throughout production, the company conducts random sampling of finished chocolate bars to test for microbial contamination, ingredient consistency, and adherence to allergen labeling guidelines. Every aspect of production, from ingredient sourcing to final packaging, is governed by good manufacturing practices, GMP, to ensure consumer safety. Beyond the standard Hershey's milk chocolate bar, the company's factories are also responsible for producing a variety of chocolate products that follow similar manufacturing principles, but may involve additional steps. For example, Hershey's with almonds requires an extra stage where roasted almonds are added to the chocolate mixture before molding. Similarly, cookies and cream variations include white chocolate blended with crunchy cocoa cookie pieces, requiring specialized mixing equipment to distribute the inclusions evenly throughout the bar. These variations highlight the flexibility of Hershey's production facilities, which are designed to accommodate multiple product lines while maintaining consistent quality. Sustainability has become an increasing focus for Hershey's in recent years. The company has taken significant steps toward reducing its environmental impact, particularly in cocoa sourcing and packaging waste reduction. Through its Cocoa for Good initiative, Hershey's invests in sustainable cocoa farming practices, providing training and financial support to farmers in West Africa and Latin America. These efforts not only help improve cocoa yields, but also ensure ethical labor practices and environmental conservation. Additionally, Hershey's has committed to using more recyclable packaging materials, reducing plastic waste in its supply chain, and lowering its carbon footprint through energy-efficient manufacturing practices. Innovation continues to drive the future of Hershey's chocolate bars. The company's research and development teams are constantly exploring new formulations, textures, and flavors to keep up with changing consumer preferences. Whether it's introducing sugar-free or plant-based chocolate alternatives, experimenting with new ingredients, or enhancing the nutritional profile of its products, Hershey's remains at the forefront of confectionery innovation. The brand has also embraced digital marketing and e-commerce, expanding its presence in online grocery platforms, direct-to-consumer sales, and subscription-based chocolate delivery services. Despite all the advancements in production technology and distribution, the core experience of enjoying a Hershey's chocolate bar remains unchanged. The familiar taste, creamy texture, and satisfying snap of the chocolate have made it a beloved treat for generations. Each bar carries with it the legacy of Milton Hershey's original vision, a high-quality chocolate product that is both accessible and affordable to consumers around the world. Looking ahead, Hershey's will continue to evolve, adapting to new market demands while staying true to the craftsmanship and quality that have defined the brand for over a century. As technology progresses, automation and artificial intelligence will play an even greater role in optimizing production efficiency, ensuring that every Hershey's chocolate bar maintains the same level of consistency and excellence. The commitment to quality, sustainability, and innovation will continue to shape the future of Hershey's chocolate, ensuring that it remains a staple in households for generations to come. The Hershey's chocolate bar, a product that has been enjoyed for over a century, is the result of a complex and highly controlled manufacturing process that blends tradition with cutting-edge technology. While the chocolate has already gone through its journey from raw cocoa beans to finished bars, wrapped and ready for sale, the process does not end there. The company continues to ensure product integrity even after distribution, keeping an eye on market trends, customer satisfaction, and ongoing improvements in production methods. Once the chocolate bars reach stores, Hershey's relies on a vast retail network to keep the product readily available for consumers. Supermarkets, convenience stores, vending machines, and online retailers all play a role in ensuring that Hershey's chocolate bars are accessible in virtually every corner of the market. In addition to traditional sales channels, Hershey's has expanded into direct-to-consumer models, offering limited edition flavors and exclusive packaging through its website and specialty stores. This move allows consumers to order their favorite Hershey's products from the comfort of their homes, ensuring freshness and convenience. Marketing plays a crucial role in maintaining Hershey's dominance in the chocolate industry. The brand has built an emotional connection with consumers, often associating its chocolate bars with childhood nostalgia, holidays, and shared moments. Advertising campaigns, social media promotions, and in-store displays reinforce the brand's image, keeping it relevant across generations. Hershey's also engages in sponsorships and collaborations, partnering with other food companies to create innovative products such as Hershey's infused baked goods, cereals, and ice cream flavors. Quality control remains a top priority even after the bars leave the factory. Hershey's has consumer feedback channels where customers can report any issues, such as damaged packaging or quality inconsistencies. The company takes such feedback seriously, using it to refine manufacturing processes and enhance overall product quality. If a defect is traced back to a specific batch, Hershey's can quickly analyze production data to determine the cause and prevent future occurrences. This level of traceability is made possible by sophisticated tracking systems that log every step of the manufacturing and distribution process. Sustainability continues to be an integral part of Hershey's long-term vision. The company is committed to ethical cocoa sourcing, reducing carbon emissions, and minimizing waste in its production facilities. Efforts include switching to more eco-friendly packaging materials, optimizing energy use in factories, and investing in cocoa farming communities to improve agricultural sustainability. By implementing these initiatives, Hershey's aims to balance business growth with environmental responsibility, ensuring that future generations can continue to enjoy its chocolate without negatively impacting the planet. Innovation is also a driving force behind Hershey's success. The company constantly experiments with new flavors, textures, and formulations, responding to emerging consumer trends such as sugar-free, high-protein, and plant-based alternatives. Research and development teams work on improving not only the taste, but also the nutritional profile of chocolate, making it more appealing to health-conscious consumers. Additionally, Hershey's has explored advancements in manufacturing efficiency, incorporating AI-driven quality checks, automation in packaging, and precision temperature control systems to maintain the highest standards in chocolate production. Despite all these advancements, the core experience of enjoying a Hershey's chocolate bar remains timeless. The simple act of unwrapping a bar, breaking off a square, and savoring the smooth, creamy texture is a universal pleasure that spans generations. Hershey's success lies in its ability to evolve while staying true to its heritage, ensuring that the chocolate remains as beloved today as it was when Milton Hershey first introduced it. Looking forward, Hershey's will continue to adapt to changing market dynamics while upholding the traditions that have defined its chocolate for over a century. Whether through expanding into new markets, refining sustainability practices, or leveraging technological innovations, the brand remains committed to delivering the same high-quality chocolate experience that consumers know and love. From the cocoa farms where it all begins to the final moment when a Hershey's chocolate bar is enjoyed, every step in the process is a testament to dedication, precision, and the enduring appeal of one of the world's most iconic chocolate brands. Producing the world's most beloved chocolate bars isn't just about great ingredients. It's a precision-driven process on an unbelievable scale. Every day, millions of Cadbury Dairy Milk bars are crafted inside state-of-the-art factories, where advanced machinery and carefully refined techniques transform raw cocoa into the smooth, creamy chocolate people love. The creation of a Cadbury dairy milk bar begins long before the chocolate reaches the factory. It starts on cacao farms located in tropical regions near the equator, where the conditions are ideal for growing cacao trees. The trees require warm temperatures, high humidity, and consistent rainfall to produce the cacao pods that contain the beans essential for making chocolate. These pods grow directly from the branches and trunk of the tree, taking around 6 months to mature. Farmers carefully monitor the pods, waiting until they turn from green to yellow, orange, or deep red, indicating ripeness. Harvesting is a meticulous process, as improper handling can damage the delicate cacao tree. Skilled workers use sharp machetes to cut the ripe pods from the tree, ensuring that the branch is left intact so that future pods can develop. Once harvested, the cacao pods must be processed immediately to prevent spoilage. The first step involves cracking open the thick, leathery shells to reveal the beans inside, which are surrounded by a sweet, sticky pulp.